Are we good? There we are. Oh my gosh, I am so sorry about that. I forgot. Hello, everyone. Welcome to Voidstar Lab. I, in my infinite wisdom, forgot that I forgot that my USB hub had USB ports that don't send data, that just charge, and I had it plugged into that. Oh, I'm really sorry about that. Thanks to everyone who stuck around. Thanks a lot for your patience. Really appreciate it. Good morning, good afternoon, good evening, good night. Um, I don't know if we live on a globe. I mean, if we live on a flat Earth, I don't know why the sun is in different places. It must be a spotlight, and who changes that spotlight? It's not me. I don't know who changes the sun. Checkmate, atheists. Welcome to Voidstar Lab. Today we're going to be returning to the project we were working on last time, which is the keyboard Cyberdeck. So our objective here is to make a mechanical keyboard that is going to become the keyboard portion of an upcoming Cyberdeck project. And I just realized that my voice is actually a little high. There we go. Oh, that's all right. Excellent. Okay, Brooke's coming in behind. I'm hearing some sounds. Oh, must be the dog. Yeah. Must be Peter the Pupper. Anyways, welcome to Voidstar Lab. Our objective today is to pick up where we left off last time and make a little circuit board action. We're gonna do a little circuit, little board. Yeah. Yes. Last time we had a bunch of problems, but I realized that last time we had a bunch of problems, but we're not gonna we don't have to worry about that this time because none of the none of those problems can possibly happen again. One of the problems was we tried to use KiCad, and it turns out that I'm not supernaturally capable of being proficient with a brand new piece of software with literally zero preparation. The second is that we messed around with a script, and we ended up just doing it manually. So neither of those things apply anymore. Today's task, here's what we're going to do. The first thing is we wired up the key switches before, like we netted them out. But I'm not so confident in how we did it, so I think we'll probably rip them back up. I think we'll probably rip them back up and start over. And we'll do them in a bit smarter of a way. The second is that we're actually going to try to route them out. We're going to try to at least get most. We're going to try to at least get part of the the right half done, because that one's going to be the more interesting side. There's no chance we're going to by the way, if you're staying for the story, this is not a narrative. There is no end point here. This will not finish today. It can't happen. We just didn't get enough done yesterday. So if you're sticking around waiting to see the end, I have many more high quality videos on my channel. Speaking of, new video is going to drop tomorrow. It's going to drop tomorrow morning. Just got approved. I have to make a few more changes, re-render, re-upload. It got flagged for no ads for some reason, even though it's about 3D printers. And I think it's because I said the word bitch in it. I think it's because I said bitch. I can't figure it any other way. Or it might be that, or I was talking about Brooke and I kissing. So I think it might have actually been flagged for no ads because I talked about kissing, which is a little weird. I didn't know that wasn't allowed. That's the only thing I can think of. The second thing is I am third thing. I'm extremely hungry. I have been futzing around with this thing since I woke up, and I haven't eaten a single calorie. So at some point during the stream, I'm gonna have to ingest some fuel because I can't make it for the next 5 hours. I can't make it for 5 straight hours without some food. Anyways, enough messing around. The Chromance is still down. So So if you remember last time, I burned out the whatchamacallits. Burned out the ESP32. Ordered some new ones. The new ones are different form factor. I didn't count. I wasn't careful enough when I bought them. I bought the wrong one. So the new ones haven't shown up yet. So I tore it down. That's the last client project, by the way. Remember from that one? Remember we're doing the last client project. So that's what we were doing. That is the last client project. So today's episode is sponsored by NextPCB. They're going to be manufacturing these PCBs when we're finished. And yeah, they're running a really generous sale right now, like really generous. Use a link in the description. Uh, use a link in the description to order your circuit boards for your next project. You'll get 20% to 30% off, and that's pretty substantial. I mean, the price is already pretty good, and that effectively means that not only are you not paying shipping, but you're also getting a bit of a rebate, or not a rebate, you're getting a bit of a discount. So yeah, whatever project you got going on, use whatever project you got going on if you need boards for it, or if you just, I don't know, if you want to make your own mechanical keyboard, there are plenty of circuit board designs online. Just grab one and send it on to Next PCB. Use the links in the description for some spiffy discounts. Ah, speaking of spiffy, while I have this window open, let's where's my Discord here? Oh hey, there we go. Calling all stream stands. Let's publish that. Oh yeah, here we go. Yeah, the merch store is up. I finally pulled my head out of my behind, and now we have some super spiffy Voidstar merchandise. We have tasteless t-shirts with giant logos. We have tasteful t-shirts and hoodies with small logos. We have stickers. You can now stick a Jink sticker on anything you want. These stickers, by the way, these are bigger than they look. I don't know why it shows them the picture is so small, but they're 2 inches long. They're quite like they're pretty big. They're about the size of a little smaller than a business card. We have magic mugs. The mugs are not themselves magic; they just have magic on them in spiffy text. Yeah, it's got the Voidstar logo on the side. You can actually get this in other things. You can get a pint glass. You can get wasted with the Voidstar logo on it. It's great. I don't endorse drinking or any sort of other thing that could possibly impact my ability to make money. Oh yeah, we have the most terrifying fanny pack of all time. This thing is horrifying. I put the background from the channel page on this thing, and the way it got split between the front panel and the flap meant that the eyes staring at the circuit boards are on top of the fanny packs. Every time you look down, my eyes will be staring you dead in the face. It's horrifying. It's horrifying. Anyways, buy all this crap. I feel like we're missing something. I feel like oh right, we have the giant we have the big logo that fills the entire shirt. And we have the small one. These are all available in different colors and stuff. The hoodies there are two kinds of hoodies. You have a premium one and a regular one. I don't know. I don't wear pullovers. I want zippers in front, and their zipper hoodies make your art like super tiny and put it right there, and that's boring as heck. So anyways, if you want that link, just type !merch, and the bot will hook you up. I just created this stuff like a day ago, so I haven't had a chance to get any of them for myself. But this is Teespring. Like I'm pretty sure this T-shirt that I'm wearing right now is from Teespring. They're pretty high. They're pretty high quality. And if you see anything else on the site that you'd love to see a Voidstar logo on, I haven't had the time to make original art yet, but don't worry. I will have original designs made, and that's going to happen eventually. Anyways, enough messing around. Let's build some circuit boards. So let's take a look at what we made last time. Cyberdeck. I'm deciding today I'm going to leave the resolution at 100%. Instead of last time we dropped the resolution and tried to make it easier to see what's on screen, and it made the what's going on here? Yes, I'd like to load the schematic. Yeah. Anyways, it was making it really hard for me to do anything. I should say. Yeah. So we've got all the project info and stuff. I would really like to do a little messing around. I'd hope to mess around with the loop deck a little. The loop brother. So that I could hide both of these things. Let me see real quick if anything funny, anything's going on here. I got a loop deck. I convinced Micro Center to get me a loop deck. That's what you see right here. It's sort of like it's like a stream deck. It's like a mullet, right? It's like a stream deck in the front, and it's like a Premiere control surface in the back. It's made it super easy. I'll tell you this. It's made it mildly easier to build or to build the video, but holy crap, is this thing useful for holy crap, is this thing ever useful for color grading? Before, I would do like just basic color grading, right? Like apply the lookup table, mess around with the color temperature, you know, maybe for scenes that were particularly blown out or under, mess around with it. But with this, I could like shoot through the entire 20-minute video, tuning everything in like 2 hours. So this is definitely the best looking video we've ever done on the channel. This is 100% the best looking, oh, here we go. Excellent. This is the best looking video on the channel by a mile. Yeah, it's a good one. Alright, there we go, there we go. Clean up HUD. So, here we are. So the reason why I'm doing this here is because I realized that before the text, right, the ask the bot, the project checklist, all that stuff, it's covering up the screen. It's covering up too much. So I'm going to throw this here so that, there we go. Haha, I should have put an animation on the bot part. Oh no, I'm inconsistent. Oh no. And let's clean this up by hiding this too. Look at that, I got a little, everything's all nicely animated now. It's almost like this is a professional stream made by someone who actually cares about the quality of his work. Let's get into this. We have some super chats to acknowledge first. We have some spiffy viewers, neither who I should who I feel like I should acknowledge their spiffy contribution. Let's see, who do we have here? I split the chat off now. I can't find it. All right. Let's see. Oh, Acalia, thank you so much for kicking us off with a very, very generous super chat. I really appreciate it. Stream hype! Also, hello Edmund, Peter, hello Brooke, hi Zack, and hello Stream. Well, hello back to you, Acalia. Thank you so much for your very, very gracious support of the channel. Edmund is no longer in this household. Edmund got adopted the other day. That's right. Edmund got, like, somebody saw this pupper at a, somebody saw this pupper at an adoption event, and he just fell in love. And now Edmund has a new home, and his name is now Dexter. He's now Dexter the dog, which I think is a better name for him than Edmund. Edmund's a classy name, but this was a real neurotic mess of a dog. So I think Dexter is the way to go. But yeah, Peter seems to be taking it extremely well. I think having his brother around is stressing him out. Peter has gone from being like a high-strung bully to like the chillest dog. Today's Mio is strawberry pineapple smash. One of these days I will have time to actually make coffee, but that's not today. Anyways, thanks a lot for the super chat. Much appreciated. A Blade of Kitten. Hello, Zackerman. I have seen ducks. I am tired. Thank you so much for your support of the channel. I really appreciate it. By the way, A Blade of Kitten, I'd like you to go to chat right now. I'd like you to take a look at this. There you go. Take a look at that. Wait, why didn't it work? Why didn't it work? I spent all night setting that. I didn't spend all night setting that up. What happened? Where are the ducks? Oh, there we go. Excellent. There you go. You wanted ducks, you get ducks. I think I put the ducks on a cooldown. I put the ducks on a 5-minute cooldown because I don't want our chat. I don't want like actual discourse being drowned out by quacky boys. Anyways, let's run a circuit board. So here's what I'm thinking. So before, we wrote all these by hand, and we tried to kind of guess where everything would end up. And that's stupid as heck. I don't know why you people let me get away with that. You people, this is all your fault. This is all your fault. I just want you to know that. So what I'm thinking is we will open up the manual and see if we can connect. So the yellow lines here are called air wires. They're nets. Basically, like, they're conceptual connections between they're like sort of like they're connection. The yellow wires are connections on a circuit board or connections on the schematic that haven't yet been laid out in the circuit board. I'm wondering, can we connect these using the command line on the board editor? So let's find out. Let's type help net. By the way, please let me know if things being so small is making it hard for you to see what's going on, because I am running it at this. I'm running it at this higher resolution for my sake, to make it easier for me to click on things. Last time I was having way too much trouble clicking on things because it's ambiguous where the mouse is. But if you're having trouble seeing anything and it's ruining your enjoyment of the stream, then please let me know, and I will change the resolution. So yeah, let's take a look at the net documentation. So let's see. Net name curve radius. It's used to draw individual connections. All right, let's take a look. Blasto Supreme, thanks a lot for the super chat. Quagsire ahead, please. Quagsire is not within arm's reach, but if he ever is, he's going to be perched on my head. Oh, am I, let's see. Looks like I turned my sound down a little too far. Aha, there we go. Yep, still working on getting the, oh, there we are. So yeah, still working on getting the audio levels right. So thank you very much for C34A for pointing out the fact the stream is a little on the quiet side. Still working on getting the volume level right. It's hard because I don't have a good way of listening to the stream except for recordings, so you know. Oh. Is there really not have a button to hide my face? Why would I do that? Not seeing anything here. Let's check the Almighty Oracle. Oh hey, it's the merch store. Let's see. Make net from Eagle board editor. Stubs. Open Eagle made 2 nets VN reset. All right. Okay, so one thing we can do here, we have a few options. One thing that we can do is we can go into our schematic editor, and we can just make a short little trace. Basically make like short little traces and just name them, and then we can rename those, I guess. Like, but that requires us to name it twice, and without the ability to write scripts, it's gonna be that's gonna be hard. I'm just thinking. Just give me a sec here. You know what? Like, I keep like my heart rate goes ballistic every time I have to stop. Every time the momentum slows down, I have to think about it, because the effect it has on the performance of the stream is to some extent catastrophic. But I think to preserve my sanity, I think we're just gonna let it all hang out. We're gonna be stopping and thinking things through. We're going to be thinking things through. We're going to be imagining stuff. We're gonna be doing little experiments. We're gonna be trying stuff. So yeah, if you're having if that bothers you, again, we got plenty more videos. Just head to just click my name right there under the video, and you'll have plenty more well-produced, tightly scripted, ruthlessly edited pieces of content. But for now, we're just going to let it all hang out. We're going to design a circuit board, and it's not going to follow a narrative arc, and it's going to have awkward pauses, and it's going to have stutter-stop momentum, because that's how building stuff works. I wish that making things was like a montage of Tony Stark like messing around with augmented reality, but it's not. So yeah, there you go. Everyone's spamming ducks. The duck command is on a 5-minute lockout, because otherwise it would take over the chat. Keep that in mind. The ducks are for consider them like the salt in the food. You have to sprinkle a little bit of ducks on top. You can't make a meal composed entirely of ducks. Every Chinese person's like, no, this guy's wrong. I could love some Peking duck right now. I could. I'd love it. Anyways, how are we gonna go about this? So we got two options here. We have the way that's easy, and we have the way that's time consuming now, but will be easy, but will help in the future. Basically, we can either have tedious. We can either have it be tedious now, and flow better in the future, or we can jump right into it and get things flowing, but the job will take much longer and we'll have a high chance of failing. I'm thinking we just do this properly. I think we just do this right. So here's what we're gonna do. I'm gonna rip up. Oh, hang on a sec. I have to group. I'm so not used to Eagle. Basically, why isn't it selecting these? Basically, we're gonna delete. We're going to delete most of these wires. You'll notice, though, that we're only going to delete the parts that are connecting the I/O expander with our keys. And that's because we're just going to name see this little bit of wire, this little bit right here? We're just going to name that, right? And then we can connect them. I think we can just rename in the future. Let me just make sure. So let's see. We're just gonna test here. We're just gonna name this thing foo. We're gonna name this one. Oh, we're gonna name this one bar. We'll flip over and let's see. Name foo bar. Huh? Huh? Well, first, let's get our grid back to using millimeters. Rounding errors. Why does this use floating point math? GWR Films, thanks a lot for the super chat. Hi Zach, are you able to show us how to code I2C OLED for shapes, etc.? I noticed you have them on this design. Pardon, cheers, love the streams. Oh, you're talking about the I use here, let me, depending on what I am doing with the the OLEDs, I am using either Adafruit Graphics or I think it's called Mono LCD. Let me. I already have Arduino open because I was working on the last client project. Oh, by the way, this is the Voidstar logo that appears on the T-shirts. I didn't just take the logos I already had and upload them because that would look like crap. I went and I traced them and I cleaned it up by hand and I vectorized them to give them the ultimate high resolution experience. Let me pull this up real quick. Libraries. Where's our libraries? Oh, let's go to the examples. What was it called? Mono LED or something? There's so many libraries. I have like 300 libraries. Depending on which board we have selected, I've got something like 200 or 300 libraries. Yeah, some of these are for things that some of these are for things that have certainly not been on the market for years, like decade even. What do we got? I completely forgot the name of this thing. It's got a terrible name. By the way, please, if you are making stuff like Arduino libraries, please make your name memorable. Don't make it something boring. Give it a name that's both descriptive and memorable. And if you can't think that up, you're not done with the project. There's no point making something if no one else can use it. I'm so angry right now. 1-bit display, that's what it's called. It's called the 1-bit display. How awful of a name is that? Because it's not even true. It's not even true. Some of these OLEDs have have 4 shades. Anyways, it's called 1-bit display. The graphics, it has a graphics library, but I find it a pain in the butt. Generally, though, I don't draw shapes and stuff. I don't draw shapes. Like drawing lines and shapes and stuff. First off, it requires you to do math, which I don't like doing. You know that. Second is that these screens don't update. The difference between loading a bitmap and displaying it on the screen and drawing a line with math on the screen, you don't tell the difference. It's going to flicker anyways because the the amount of time it takes to load and render the bitmap is nothing compared to the amount of time it takes to update the display. So it's not, just do it in a bitmap. Like, make a GIF, split the GIF apart in individual images, and throw them up there. And if your board can't store all those images, then use a different board. Yeah, like a Teensy you can store bazillions of images on a Teensy. Anyways, Adam Bryant says FUBAR is actually an acronym for F'd Up Beyond All Recognition. I know I'm supposed to go yes and, but that's incorrect. What you're thinking of is FUBAR. FOOBAR is a polysyntactic variable that has, as far as I can tell, no relation to the military phrase. I think it was originally part of a much longer sequence. It's sort of like lorem ipsum. Yeah, it's not FUBAR. I also don't usually use it. I usually use bat and man, because I think that's funny. Because then you get bat and man, and then if I'm like working on string comprehensions, I can concatenate Joker or I can concatenate Robin, so it's Batman and Robin. That just makes me happy. Is everyone trying like random objects? Everyone trying like yeah, everyone's trying random commands to see what other emotes you'll spam. There aren't any others. It's just ducks. It's only ducks. That's it. That's it. I put this one in. I put this one in just as a joke for a single viewer, because I'm cool like that. So let me think. All right, let's go. Let's pull up another help page, and we're gonna do name. We're gonna see if we can name stuff from the command line. How do we do it? Name, old name, new name. But how? Parts, elements, pads, SMDs, pins, and gates cannot be selected by name, so that doesn't help us. Other object types, nets, bus signals have to be clicked first. So this won't help us. We can't. So there's no possible way that. All right. So never mind. There is no possible way to edit the to pick names from the. Or to. There's no way to wire this up from the board editor. We have to do this in the schematic editor. So this is also why I wanted to keep things full resolution, because if I had this at the resolution before, this window would be like 400 pixels wide. Yeah, so let's see. Let's see how we're going to do this. I'm going to... First, let's move this into position. How do we want to do this? I think we probably want this thing to sit. Do we want it in the middle? I don't think we want it in the middle. I think we want to leave as much contiguous area as possible. Like right here, we want to leave as much contiguous area as possible so that we can implement a microcontroller. Because, although maybe, I'm thinking about this here. Maybe it makes more sense to put the microcontroller on the other side. No, that would leave a margin. No, the microcontroller's got to go here. So... With a super chat. Akelia, thank you so much for the very generous super chat. Medicine tactic variables. Fubar, Baz, Kuz. Oh, yep, there it is. There's the whole thing. Yeah, I don't know where they came from, but as far as I know, it has nothing to do with the military. Yeah, I'm not even. I think it might even predate. I might even predate it, because I think the Fubar acronym is from the 80s, but the Fubar, the variable, I think is from the 70s. Yeah, let me think. Hand Gaming says, Zach, do you have any starter projects that you think could help a new person in the area of electronics? Yeah, absolutely. The thing that you want to make. Don't worry about how complex it is. Electronics, no matter how you try to get into it, right? No matter whether you're trying to learn it systematically or you're just diving in and, basically, it's hell. It's absolute hell. You are talking hundreds, possibly thousands of hours before you're even close to proficient in it. Like, just to put your chips on the board, it's going to take a few hundred hours. So you are going to need a project that drives you forward. You're going to want something that you are going to not just lose sleep over, right? Not just like ignore your friends over. You're going to be losing sleep, ignoring your friends for possibly years. So pick something that's gonna fire you up and drive you forward through that. For me, For me, it was a Nerf ammo counter followed by a heads-up display. I just could never learn it until I came up with those two projects in succession, and I spent months trying to build them, probably over a year total between the two of them, and that's what got me into electronics enough that I could kind of bootstrap the rest of the way. So whatever project is whatever project is going to keep you obsessed, and I don't mean like interested, I mean consumed. I mean you'll skip meals for it. I mean like you'll say, I haven't been in the company of my preferred person in 6 months. Well, maybe I'll go out after I finish this part, like that. Figure out what that is and do that project. Yeah, pick something that you're going to stay obsessed with. It's not just enough to be interested; you have to be consumed by it. Aaron Bryant says something with a 555 timer. Man, you just really want to pick fights with me. 555 timers are obsolete. It is literally cheaper to buy a Cortex M0 processor than it is to put a 555 timer in there. It's literally cheaper to use a microcontroller. Whatever project is going to fire you up. It also, I guess, like to an extent, also depends. I'm gonna keep messing with this thing as I talk. It also depends what you're trying to learn. I assumed you wanted to learn how to make electronics from, like circuits and stuff. But if all you want to do is like learn the fabrication techniques, mechanical keyboard is a pretty good first project because it's just a lot of soldering. And it's useful. If you're interested in just making circuit boards, you don't have. If you just want to make a circuit board, like you don't have to design the circuit board. There are open source circuit boards out there, and it's not difficult. It's not difficult to go from like if somebody has a finished circuit board, it's not hard to actually have that printed. You need to convert it to some files. I broke a drill bit the other day, first time. I need to convert it to some files that are printable called Gerbers, which are sort of like the circuit board version of STL files. Sort of. I guess basically, yeah. It's more like G code, sort of. Anyways, that's very easy. So yeah, I think that's a pretty good start. Yeah. I would recommend start with use name brands, Arduino, Raspberry Pi, because the more popular platform is, the more libraries and documentation will be available. So let's get back to work here. All right. So how do we want to lay this thing out? Before I was very hasty because like there's I gotta maintain momentum here, but I want to be much more methodical. Yeah, I want to be much more methodical here because the smarter we are in laying this out now, the easier it'll be to route it later, and the easier it'll be to make changes. This is one of the big problems is if you just bull through it and you make a sloppy circuit board, it becomes very hard to move anything around and make any changes because you end up like if you are able to route the board, then you end up routing it super tight and you got tons of wires crossing in every direction. It's a giant mess. Yeah. Gregory Sakharov says, Zack, what's a program to start designing boards? I'm using... Pardon me talking with my mouth full. I have to continue talking, but I also have to eat. I'm going to pass out. Let's see. At one point, it would have been... like, I'm using Eagle. At one point, it would have been a super easy Eagle recommendation. But as of now, the only thing I can recommend is KiCad. I don't know it well enough to use it on stream yet, but you gotta use... yeah, just use KiCad. It's come a long way. It's matured a lot since I first tried to use it a few years ago. Eagle is now on a horrible subscription model, and I can't endorse anyone spending any money on a piece of software like that. On top of that, like there's difference between 3D models and circuit boards is that if Autodesk eventually screws us over, you still have you can take your STL files and you can take your STL files and load them into another CAD program. It's not the best, but it'll work. With circuit boards though, you're screwed. There's no good way to convert an Eagle board into a KiCad board. So I would just use KiCad. I'd like to say Altium. I personally, that's my favorite, but it's very, 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 very expensive. So at some point, hopefully they realize that there are makers out there, and that those makers, it's fine if you sell them the product cheap, because when they become professionals, they'll buy the expensive version. They haven't figured that out yet. So, if anyone's listening, do that. There are other options, but I don't see any reason to use something other than Eagle, which is now part of Fusion 360, KiCad, or Altium. KiCad's the smartest choice, though. I'm not using it because I don't know it. I don't have the luxury of being able to learn things. I have to... I get kind of screwed over every time I try to do something that I'm not experienced with. The level of performance demanded of me as a content creator is just too high. But you got a blank slate, so use the right tool for the job. Yeah, a lot of folks like KiCad. A lot of folks are disappointed that that I'm not using KiCad. You know what? I'm just gonna have to disappoint. We tried it. I gave it a good college try, but it's not a piece of software. None of these softwares, by the way, no CAD software is pick up and go. Even Tinkercad, I had to F around with it for like 3 hours before I knew what the heck I was doing. Let's connect some things. So before I connected these by columns, right? We had these 5 connected here, these 5 connected here, and that would have concentrated all the traces running horizontally. Instead, we're going to connect this by rows. We're going to start with the bottom row connected here, and the next row connected there. So, yeah. Luckily, I have these numbered in a sensible way. All right, and luckily when I made this is something, by the way, that I see in so few mechanical keyboard schematics, and that is lay out your schematic the same way you're laying out your board. Schematics are not engineering documents that are printed on sheets of paper and tacked onto the wall anymore. You don't have to split this thing into sheets and cluster everything by functional groups. This document can be as big as we want. It doesn't have to have a frame around it. So make them it's so much easier if the schematic representation is the same as the board. Damn, this pisses me off. So yeah, let's wire this thing up. So we're gonna go with these 3, and we're gonna start at the bottom here. One thing before we get too deep into this, one thing that's been eating at me is that this is a fairly fine part. It's got fairly small pins. It's possible to solder this thing with a soldering iron, right? If you have flux, it's going to be a little awkward, but it's not hard. It is harder than just doing like surface mount soldering and just basically, what do you folks think? Is this going to be too difficult to solder? This, if you're watching on an iPhone, this is going to be about the actual size, give or take. So this is going to be I think these are 0.4 millimeter pitch, I want to say. Yeah. What do you think? Have you ever soldered a fine pitch SMD part before? Have you done drag soldering or whatnot? Let me know in the comments section down below. That has started to piss me off, by the way. I'm gonna route this thing as I rant. That has started to piss me off. Like, bitch, I know where the comment section is. Like, it's so presumptuous. All right. So looks like, all right, so these are our addresses, 28, 29, 27. So it starts at 26. All right. Like, I know where the comment section is. This ain't my first rodeo. Yeah, I just find that funny. We're going to connect these switches here to pins on the other side. make sure to smash that subscribe button. I also think that the notification bell is a placebo button at this point. I don't think it makes any difference. I think YouTube is already going to. I think if you have notifications turned on, YouTube is already going to just randomly pick who gets notifications. Hit that bell. Colin Ames says, Zach's a bit fired up today, huh? Yeah, now that that dog is out of the picture, I can actually get a full night's sleep. Peter's quiet as heck. He's a quiet pup. Not like that barking bitch, Edmund. Oh crap! I said bitch. Oh crap! I said crap. All right, so let's start with this guy here. All right, so this dude, we're gonna bring this up over here, and we're gonna connect this to pin. Here we are, pin 26. This is gonna make the schematic look a little weird, but that's fine. By the way, this is a very random question to ask everyone, and thanks to everyone who's telling me how hard it is or easy it is for you to solder small surface mount components. This really makes a big difference. If it's too hard to solder this part, I'll replace it with a leadless version and just sell the boards with the surface mount soldering done already, because there's no good through-hole version. Yeah. So let's see. This guy's gonna go 25. We have to be careful not to actually click on the board editor, or let's see. Sorry about all the zooming, by the way. I tried to get the space mouse working with Eagle, but it didn't work very well. So sorry about all of the weird scrolling and whatnot. It's kind of the only way to navigate the software. Again, if it's if it's making you nauseous, then let me know and we'll do it anyways. Doesn't matter what's. I prefer to make life easier for myself, but at the end of the day, you folks are the only priority. Hey, so yeah, so this goes to 25. All right, so then these are gonna go. Let's see. All right, excellent. So this is gonna go to pin. Wait, where's where's 23? Oh, it's the voltage pin. All right, so this is gonna go to 22. Very nice. Oh, you know what else? You know what else is new for my next video? Fresh music. I was using the same tracks over and over again, and it's I like keeping it fresh for my peeps, but more than that, I can't use the same track too many times, or it makes me overexposed to getting my channel destroyed by copyright strikes. So I added some fresh music, and yeah, this episode's good. This one is good. It is. Talk is cheap, but this I really like the way this episode came out. This is a fun one. Oh, I'm so excited. I wish I could have put it up earlier. What's going on here? With these, how many 1, 2, 3, 4, 5, 6, 7. So this is the split. This is where we decided we do the split between the two, because this thing is about as long as 3, was it? About as long as 2. So we're gonna do. So only 5 rows should be connected, right? Have I messed this up already? Yeah, I messed this up already. Huh. Excellent. Excellent. Wonderful. Pardon me. That's what I get for talking with my mouth full. Alright, here's what we're going to do. We're going to grab a wire. I'm going to make it something really noticeable. There we go. We're going to make this dashes. We're just going to mark or the place we're splitting the board in half. So the screens are about the size of 2 switches. So we got 12 total. So we're going to split those into 6 and 6, 7 and 5. All right, 1, 2, 3, 4, 5 right here. So there we go. So we've blown it already. There we go. Now we've unblown it. Everything's fine. Everything's fine! So this guy here. Oh no, we can't make this. We can't make the wires a dash. That's not a good idea at all. So this is gonna go to pin 19. Yeah, pin 19. We have to do this away, or if I drop a junction there, it's gonna combine all 3 wires. Oh, Eagle, you so crazy. This is, by the way, this is why I recommended. This is why I recommended KiCad instead of Eagle, because Eagle is just so idiosyncratic. Not that it's a bad thing, right? Like you, I'm working fairly slow here because I'm holding a conversation, I'm holding a parasocial conversation, but you can actually get an extremely fast workflow going on Eagle. It doesn't make sense to put. Like, I'm just thinking, like, it doesn't make sense. I think the top row the top row and the switches we're gonna put on this side. Yeah. Anyways, you can get a very fast workflow going on Eagle, but it's very idiosyncratic. You need to use it for a long time before you get enough of an intuitive handle on its quirks and weirdness that that you're actually fast. Yeah. So, yeah. Remember, no matter why you're building stuff, no matter what you're in it for, time is always your scarce resource. If it's a hobby, remember, maybe you don't live in America, fine. But I'm, from speaking as an American, the world does not want you to have the culture you live in does not want you to have hobbies. Everything will try to pull you away from it. So get your projects done as quickly as possible. What's that sound? I hear something shifting around. The hell is that? Oh, it must be windy outside, and there's the trees scraping against the wall. Oi, Gevalt! So folks are asking, why is the chip diagonal? Because we are going to have a lot of traces fanning out in a lot of different directions. And I'm sorry for not crediting your name. I'll be with you in a sec. We're going to have a lot of signals fanning out in a lot of different directions, and it makes it easier to route. Yeah. Yeah, that's it. There's no stylistic reason or anything. It just makes it easier to fan out a ton of signals if the part's tilted. If you ever notice, like the @mega chip on an Arduino is, yeah, it's because I'm tilted. That's oh, everyone's a comedian. Pardon me. If you notice that the @mega chip on an Arduino is tilted, the processor on old computers is tilted. You see this often when there are a lot of signals being fanned out from a chip that has the pins on the edge of the chip. If it's a ball grid area or something, it doesn't matter what orientation it is, because you're going to be fanning the signals out vertically into the board instead of sideways across the board. So, yeah. We've got a few people talking about reflow. Yeah, reflowing a board is super easy. You can do it with some really cheap and delightfully hacky equipment, but for the purpose of selling a kit, or at least putting the instructions up online, I can't assume that anyone can do that. We have to assume that all people have is 45-watt fire starter from Home Depot. Or not from Home Depot, from Radio Shack. And yes, I know Radio Shack's been out of business forever. It's a really old soldering iron, and the tip is about 1/4 inch wide. Like, we have to, when you design an electronics kit, you have to assume that a not insignificant number of people are going to solder it using pipe soldering equipment, like a soldering gun instead of a soldering iron. And you bet your ass they will complain if they can't solder that board. Yeah. Check the acid resistance of your components if you're making a kit. Plumbing flux is acidic. And this isn't a problem with most parts anymore. Most most components actually resist acid pretty well now. I don't know how that became a standard feature, but it did. But every once in a while, you know. Let's see. Yeah, this is going much easier. So by routing them this way, we should be able to. Where are we here? Did we already route 10? Yeah, we already routed 10. Yeah. So this should make it pretty easy to route the rows together. This will. Yeah, the priority here is to try to make sure the traces are predominantly moving, or predominantly like traveling like vertical or horizontal. When you're laying out a board, you want to avoid to the best of your ability making wires have to go vertical and horizontal, because either your board has a ton of vias. Basically, you want all your wires to go horizontal on the top and vertical on the bottom, or vice versa, because that minimizes the risk that you're going to have two wires parallel to each other on top of the board, which makes it impossible for you to route a wire in the opposite direction. Kuburama Uchiha, I slaughtered that. Looks like we have a Naruto fan, though. Asks, will this be a cut video on YouTube? Unfortunately, we don't have the resources right now to cut streams. It's something that I'd really love to do, but we just, between Brooke and I, the two of us just don't have the time to do it. Cutting a stream is far harder than it sounds. Like, you'd think that it's just like, oh, just take what you already did and put it on a stream. But no, you have to take what's fundamentally, like, a stream is an unstructured activity, right? Like, I'm talking, like, let's not kid ourselves here. Like, I'm talking to you while I build a project. Like, this is a fundamentally unstructured activity. But a video needs to have a narrative. So it's not just about finding the best parts and pulling them out. It's about constructing this into a story that follows a narrative arc. And that is brutal. It's so hard. I think that's actually a pretty good challenge for filmmakers. If you're interested in, like, you know, working on your filmmaking ability, trying to cut a stream down is a great challenge. There we go. Yeah, let's merge that crap in there. Yeah, it's a really good challenge because you have to create the story using nothing but cinematography. You can't use you have to create the story using pure cinematography. Oh, wait a second. We were going to do these last two rows on the other side, right? Yeah. So let's delete this. So it's a pretty good challenge for learning. Let's do these guys here, for teaching yourself how to cut stuff. Okay, so check this out. This is how this is going to pay off. This is how I was talking about before. Directions is going to pay off. So before we routed the wires that are going to go to the board here, right? So these are going to go down, like these are going to go briefly down, and then or these are going to go down to here and then fan out this way, right? They're going to go like doot doot, and that means that to connect these, it's going to be really easy, right? All you have to do is go like this and then down, because these are on the switches are on the top and this is on the bottom. So yeah, we've made our job a lot easier, and we've drastically reduced the chances of having anything overlap. We also have to remember that this area here is not open. In fact, I'm going to remind myself of that because I don't trust myself in the slightest. So we're going to create a rectangle. There we go. And we're going to put this on the bottom keep out layer. There we go. Yep, bottom keep out. And this is to remind myself that I am not allowed to use this area. I'm not allowed to route traces here, because we're going to need this. I can't route traces here because we're going to need this area for implementing our microcontroller. Got big brain plays here. Other reason, I just realized something. It makes more sense for this to be at the bottom, right? makes more sense for the I/O expander to be at the bottom of the board because we want to put a USB port at the top of the board. And because we were smart, give or take, about how we laid this out, it's not that hard to move this thing. It's not gonna substantially, we're not gonna make this board substantially harder to route by moving this I/O expander. Yeah, there we go. We're still gonna be doing the same approximate things, going this way and then going up. Very nice. Oh, the face cam's blocking what I'm pointing at. Sorry about that. I wish I could overlay that onto my screen here. I'm sure there's a way, but I'll be damned if I know it. Anyways, I want to leave this area free so we can put a USB port here. So let's return. So this is going to go like so. You know what I'm thinking? I'm thinking we should just go over here and just route these traces. Before we get too deep into routing, laying out the other side, figuring out which traces go where, I think we should route these, because that will help guide our progress here. So let's do that. Let's just make sure here. Okay, so we're gonna go diagonal. So we're gonna set this to go. Let's see. Diagonal, then cardinal. And I'm going to zoom in here. Let's just make sure, yep, we got a problem here because the trace is bigger than the pad. Generally a bad idea. Alright, so this is going to be an awfully fine trace. What a fine trace! Yes! Let us take a look at what this is in inches, or in mils, just to be sure. This is a 10 mil trace, that's fine. That's fine. Actually, no, I'm not. I was just about to say, Osh Park lets us go down to... Oh, I missed a super chat. Oh, my. Oh, no. Oh, I'm such a monster. I'm such a beast. Oh, no. Marty, thanks a lot for the sticker. I really appreciate it. I like the cool sunglasses. Future's so bright, we need shades. So, yeah, I was about to say, Osh Park lets us go down to 6 mils, but we're not using Osh Park. We're using today's sponsor, NextPCB. .com. Use the link in the description to get 30% off your order. It's not an exclusive offer for me. They're running a sale right now. Only $0 for 1 to 4 layer PCBs. Yeah, they have a bunch of discounts going. They're trying to drum up sales and presumably kick JLC PCB's ass. So yeah, use NextPCB. The boards are high quality. They have a little trial going, but yeah, they have a little trial going. The boards are pretty high quality. Unlike JLC PCB, NextPCB also does plated slots. They'll do milling and they'll do other operations because their system isn't fully automated the way JLC PCB's system is 100% automated. So they will they can't do slots and stuff because those have to be manually entered by a technician. So let's take a look. PCB capabilities. There we go. Go up to 20 layers. Jesus Christ. Dimension tolerance, 0.15 millimeter. It's not the best, but you generally don't want to rely on tolerances that tight anyways. Oh, man, they got options for copper. I didn't even realize this. Go up to 6 ounce copper. That is thick. That's like that's like half a millimeter of copper. A millimeter? It's like half a millimeter of copper. Minimum clearance, trace and space. There we go. Oh, man. Okay, so we can... So we're going to be making a 1 ounce board. So our minimum trace and space is only 3 mils. That's very small. That's yeah, that's very fine. I'm not like, and this isn't part of like, this isn't a sales pitch or anything. Like here, let's go to Osh Park real quick and compare. Let's see, Osh Park services, the prototype trace. Yeah, so they want 6 mil trace, 6 mil space, and NextPCB does 3. So either way, we're in the clear. We're fine. A 10 mil trace is more than enough. But let's switch our grid back on and bring that back to inches. No, we weren't in inches. We were in millimeters. Why do we keep having rounding errors? So yeah, let's route this thing. This is my favorite part of the process, by the way. This is the part I look forward to back when I was a full-time professional prototype developer, because it's just like solving a chill puzzle. You know, like put some music on. All right, let's move this up. Make life a little easier for us. Yeah, you know, put some music on, maybe play a little YouTube video, you know. Yeah, let's put this guy here. Put on a little video. Chill out. Route some boards. You know how it do. So we're working on a millimeter grid, and I know that's not really conventional. Like it's most of the stuff is done on. Here we go. Most of the stuff is done on an imperial grid, but I'm trying to switch everything I do over to metric. In part because 3D printing is almost always in metric, and I want to standardize that to make sure, so I don't have to convert dimensions when I'm building one around the other. So let's put ourselves in a 0.5 millimeter grid, or is that going to be too fine? I think that's fine. What is that? 1 millimeter is 0.127 inches. So this is it is a 0.6 millimeter inches. Minnie says, in the past I've described a PCB routing as solving a puzzle with no solutions. Definitely enjoyable experience. That's a really good it's a really good way of putting it. I totally agree. It's a lot it feels a lot like solving a puzzle, but there isn't a correct answer. There are smarter and dumber decisions, but there is no pre-made solution. I know it's possible to an extent to route traces. I know that to an extent it's possible to route traces like together. You can like grab a bunch of them, but I don't think they'll really help us because our traces are spread out across such a wide distance. It's more for connecting pins that are already parallel. All right. If you hear me if you hear like the click release, control right click toggles. So each one of these modes, right? Each one of these, I don't know what they're called. Basically, Eagle will bend the wire for you automatically, and each one of these has 2 of them. So it can either go like vertical then horizontal, or horizontal and vertical, or it can go cardinal then diagonal, or diagonal cardinal. And if you hit control right click, it'll switch between them. So you'll hear me doing that a lot as I process the board. Yep. Let me just make sure that my PC's sound is off, because for some reason Eagle plays the Windows notification sound every 1, 2, 3, 4, 5. I guess did we decide against this guy here? Yeah, you know what? I'm going to take this guy. All right, I'm gonna take this key here, and we're gonna put it back in our grid here, because I forgot that this isn't lined up this way. It's in the middle. And we have more keys on the left side than the right side, so I want to take as many keys as I want to take as much as we can and connect it to this one. So let's go. So we're gonna be splitting the board here. Awkward. I think it's gonna be fine. It's gonna be fine. It's fine. Everything's fine. So let's take this. Come on. Come on. There we are. Hard to click this stuff. Right. So this one's here. So I'm guessing this goes here. Yeah. Boop. There we go. Beautiful. So let's route that up. So why I like Altium, by the way, is that the workflow for routing traces on Altium is much faster. It'd be a little awkward for me to explain it without like showing it, but like suffice to say, routing traces in Altium is significantly faster than routing traces on Eagle. All right, so now look at how little space this took up. By the way, look how little room this is. I don't know how close. We also have to assume that we're gonna have to move traces around a little bit because they might be spaced too close together. You know what? Let's do a DRC real quick. I'm gonna load we're gonna use the Oshpark DRC because it is. There we go. We're gonna use the Oshpark DRC because it's it's more conservative than than the one we would need, and if we can make, there's no like, sure, they might let us go down to 3 mil trace in space, but there's no reason to push it that far if you don't have to. All you're doing is increasing the chances that something breaks or shorts in the manufacturing process in return for nothing. So let's see, what do we got? Nothing, no errors. Okay, good. So let's save. All right, so we got no errors. That's fine. That's great. That means we have plenty of room between these. So here's a question: we got 5 of these. Can we route them all down here, or do we want to go upwards? I think we should stay down here if we can get away with it. Wait, did we mess this up? Oh, I connected 2 to this. Oh, yep, I messed it up. I connected 2 to the same net. I blew it. Do we have any here? Do we have any signals here that aren't that we're not using? I don't think so. I think we did all of them. We'll deal with that key last. Or yeah, we'll deal with that one last. I guess we could also wire it up to pin 5. Let's just do that. Let's just do that. Oh, what's going on here? Come on. Why did because I still have the delete tool selected. All right, where's pin 5? And we're not using this one, right? It looks like we are, but we're not. See right here? It looks like these wires are connected, but notice that there's no junction. Over, like, wires that don't have a junction. Oh, come on. Wires that don't have a junction are not connected. They're overlapping. Cool, cool, cool. So let's just route that one real quick. All right, this isn't the tidiest layout, but we can remember we can always change it. If we're designing our board in a sensible way, then we have a lot of latitude to change things. Here's a question: do we want to leave clearance for LEDs? Do we think there's a chance that we're going to want to add? So I'm not planning on adding LEDs right now, but the question is, are we going to add LEDs in the future? Maybe we should also line up the. We could line up these OLEDs with the buttons, but they're not the same size, so we've got a bit of a problem here. So, but I'm still going to move them around to be on about the same grid. So the question is, do we want to leave enough space to route or to add LEDs later? I'm thinking no. I shouldn't solve problems until they exist. So let's space these out properly. So this one here is let's see, it's at y of 0. Oh, this is going to be super easy. And this one here has a y of minus 75.5. So we're just going to take minus 75.5 and divide it by 5. So each one of these is going to be spaced on the 15. Minus 15. There we go. Minus 15. So this is just going to space them out evenly. I'm sure there's an automated way to do this, but I'm not going down the Eagle automation rabbit hole. Yeah, let's see. My threshold for automation is if I find myself doing something at least twice a week for at least, I say at least 3 times a week for at least 3 months, then I will consider automating it. But if it's any less than that, I don't think it's worth it. There we go. Now they're spaced nicely. Very wonderful. Wonderful. How do we want to do this? Let's rip this guy up and let's route from here. There we go. All right, we're just gonna. So the only things let's see, we've got the address pins here, right? We've got address pins, we've got VDD and VCC. So all you have to do is leave enough room for vias, and we're fine. Another thing we can consider is if we're going to make this, well, actually, I think I underestimated how important this is. If we're going to make this a multi-layer board, basically if we're going to make this a 2-layer board, or if we're going to go all the way up to 4. And why this is important to figure out now is because we're going to have so we're relying on yeah, it's coming a little too close. I don't like that. We are relying on our ground plane to connect one side of all these switches, but we're going to have a grid of wires splitting up the ground plane. So we're going to have to add a whole bunch of... we're going to have to be very careful to make sure that there's always a signal. All right, this isn't a decision to make now. We're going to route the thing up, and if it's turning out to be too much trouble... Let's see. Yeah, we're gonna route it all now. If it's turning out to be too much trouble to get the ground going correctly, then let's see. If it's too hard to get the ground connected, then we will simply add another layer, add a ground layer. All right, we don't have to worry about getting this perfectly. There's no chance of a mistake this egregious getting into the final product. Like a mistake, like I know this is overlapping. Don't worry about it. It's fine. So which wire is this? Oh, there we go. Yep. I use the rat's nest to clean things up. Rat's nest recalculates these air wires. It does a bunch of things, but the one we care about is it recalculates these yellow air wires to give them the shortest possible distance. So there's no so like right here, I routed it such that the trace is overlapping a pad. Don't worry about it. Like there's no chance that we're gonna forget about that because the DRC the automated check that we run will detect overlaps. It's actually a little too zealous about detecting overlaps. Yeah. Divine Fools Club says, dumb question, why not just auto route? Auto routed traces are never as high quality as hand placed traces. They're never going to be as good. Let's see. I've realized we've made a we've made a mistake here. Now that we've moved this down, the wire, these are going to have to cross each other. We don't want any overlap. I'm just thinking, is that necessarily the case? Yes. All right, so we want to reverse these. Is that the case for all of them? Seems to be. Would it be easier to just turn this 180 degrees? No, we're gonna have to edit them. Cyberdeck Cafe says mechanical keyboard is the biggest time sink when building a deck. It's totally true, and that's the reason why I'm streaming this part. In total for this board, I believe off the top of my head, my estimate is I'm going to have to route... This thing is technically 2 boards, so I'm going to count them as such. Depending on whether I implement the power management myself or if we use an off-the-shelf board, we're probably going to have to route somewhere between 6 and 10 boards. But the other ones are going to be they're going to be trivial. Like we're going to have one that's just a Raspberry Pi and a HDMI connector, more or less. So let's switch back to our... First, let's save before we mess something up. Let's switch back here. So we got our first row, and that goes from here to here. So yeah, so there's no good way to do this automatically. We're gonna want to switch these. Let me think. Gareth Smith says, "Why not start with auto route and drag around the stuff you care about?" Well, the problem with like Eagle's auto routing isn't interactive. Like you have to recalculate it, and it just gets awkward because it just gets really awkward. It's also very hard to verify an auto-routed board, and the problems it causes, like, it works. Don't get me wrong here, they work. The problems they cause, though, are that they make the board harder to maintain down the line, and it's very easy to auto-route your way into a situation you can't route your way out of. The other thing the auto-router won't do, and this is why I'm going back and forth so much, it looks like it must seem like I'm making a lot of mistakes. But it's not the case. The auto-router will only route the traces and will only route the nets that you place between the parts that you place. It'll never say, "Hey, you know, this works, but if you were to move this part over here, or if you were to swap the pins for these 2 buttons, this thing would route a lot cleaner." It won't do any of that. So cutting corners is Cutting corners has consequences. So let's put these back next to each other. There we go. Oh, that's not what we want at all. There we are. I'm glad the Cyberdeck Cafe is here. This is definitely... but calling this project a Cyberdeck isn't totally accurate, because it is... I'm trying to make a circuit board that doubles... I'm trying to make a Cyberdeck that doubles as a mechanical keyboard. So you don't need to make... So if you're interested in this project, like, you won't need to make a Cyberdeck, right? Like, you can just fab the keyboard part and use it as a mechanical keyboard. Because I know that Cyberdecks, unfortunately, are still a bit of a niche project. Let's see, net. There we are. Yeah, unfortunately, Cyberdecks are still a bit of a niche project, but mechanical keyboards aren't. I guess they're still niche, but they're bigger niche. All right, so we want this to go to pin 21. So yeah, if you're interested in making a mechanical keyboard, this is going to be a cool one. So I think this project is actually going to serve triple duty the way I'm designing it. So this is going to be sort of like you can make the Cyberdeck, or you can make, so this is going to be a split keyboard. You can make both halves of the split keyboard and have yourself a spiffy split keyboard, or this thing is going to have a bunch of buttons with displays on it. I'm trying to get both the pin number and the thing I'm routing in view. Oh, this one's the one in the middle, so it's going to end up in the same place, right? Let's see, 2120. Yep, there we go. Yeah, so this is going to have buttons with monitors inside them. Am I wiring up the wrong? I'm wiring up the wrong buttons. I'm so dumb. Aren't I? Yeah. Oh, no, I'm doing the right to left. Man. Routing circuit boards is tricky. So this is going to pin 19. All right. Anyways, we'll be able to make just the right half and use it as a macro pad. Use it as a macro pad with image buttons on it. It's not going to be as useful out of the box as a full-on Stream Deck, because I haven't wrote I won't be able to write the software for it. But I still think it's going to be pretty neat. Why do we have this connected to pin 7? What did I mess up here? What did I mess up? What did I mess up? Pin 22. Oh yeah. All right. I messed it up already. All right. There we go. Yeah, man. Routing circuit board, CAD in general, these CAD programs demand your complete attention. All right, so we want the furthest switch to go to pin 22. So let's see, pin 22. There we go. We'll delete the extra junctions and wires later. So we're still in the net tool. So pin 21 is next. We're going to go from here to whatever switch is next. There we go. Then we're going to go from here, from the middle one on this half, over to pin 20. There we go. All right. Isn't it easier when you focus? I've been picking fights with people on Twitter a lot lately. I'm probably going to end up getting canceled about this. But basically on a podcast I did with Chris Gamble of Contextual Electronics. It wasn't the Amp Hour. It was his own personal podcast. He has his own podcast. Anyways, we got talking about engineering. We got talking about like engineering as what's the way you'd say it? Like we got talking about basically why the demographics of hobbyist engineering are so skewed, even years after, like, even with basically you have a really diverse assortment of, you have a very diverse group of people studying engineering in school, but I've found that engineering as a hobby is a lot more homogeneous, and basically we were talking about like why that is, and what I said was that engineering is an intrinsically solitary hobby, and I think that some demographics just are less lonely than white guys. I mean, white guy, like a lot of lonely white guys out there. Uh, Again, like I'm not asserting that's fact. I don't have any data to back it up. It's just a guess. But that's not what kicked the hornet's nest. Oh no. Oh no. 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 The thing that pissed people off was the fact that I said engineering was solitary. That is why I'm going to get canceled, because people really do not like this idea that stuff is better off made on that, like people really want to think that engineering is collaborative. What happened? Wait, what's going on? Oh, you have air wires. All right. Yeah, I think there's this narrative. I don't know the exact. I'm still figuring out what the exact dynamics are, because I think there might be a video in it. But basically, people are burning my people are like burning my Twitter down about, like, no, engineering's like a team activity. Like, you know, it's all about collaboration. You're never going to make good work if you're alone in your room. And I'm like, I never said it's not collaborative. Like you have to have multiple people on a project just to get enough person hours in there to to build the thing, right? You know, like you want a lot of viewpoints. Let's see. You want a lot of viewpoints. You want a lot of perspectives. Like, I'm not arguing that. I'm saying what I said was that engineering is a solitary hobby, or solitary in general. And all right, granted, there's a there's some loaded semantics there, right? People correctly ask me to nail down my definition of engineering, and that's fair. That's fair. I think the semantics of something like this are very important. And I had to carefully think through the nature of the issue. But but I'm standing by it. I think the actual work is solitary. You don't get, like, I'm routing a circuit board right now, right? This wouldn't be helped by someone else in the same room as me. Like, engineering is not a two idiots, one keyboard situation. You don't have two people modeling the same. Maybe you do have two people modeling the same model in like a fancy pants industrial context. But you don't have two people typing the same code. Pair programming exists, but it's for you don't. As far as I know, you don't do pair programming for the bulk of the project. You do it for specific elements. And you do it at specific points. Basically, like, you write most of the code first, and then you review it and edit it collaboratively. But, like, no, you meet up, you figure out what you're going to build, you figure out how the parts are going to interact, right? Your APIs, your interfaces, the size of the board, your bill of materials cost, all that stuff. You figure out the customer requirements, or you get an idea of it, or you figure out what you don't know and you want to test. Basically, you come together, you make plans, and then you break, and you do your engineering in your own office. Hopefully you have an office, because I can't imagine doing engineering in a cubicle. And the way this, so, like, I think engineering is inherently solitary. And Garrett Smith says, how do you build $1 billion project without an F-load of people? Again, not saying you can't have multiple people on the same project, right? You need to spread the work around, but they don't work together. They don't do engineering together. And when I say engineering, I mean specifically programming, modeling, testing, laying out circuit boards, speccing out parts, designing molds, like the actual the technical work. The technical work is solitary. The people work together, but they don't literally. They work together in the sense that they're all on the same project. They're not working together in the sense that they're pulling the same rope. And first off, I found there are actually organizations that do work that way, that do actually put two people at the same desk. And I don't know how. There's no way. I have a very hard time believing that most people can produce their best work when they have to split their attention between the task at hand and the social dynamics of having a coworker sitting next to them. But, like, they do exist. And of course, don't get me wrong. Engineering has become massively more diverse lately, and that's and I think that's very important. My alma mater, Stevens, had a big part to play in this. They're the first engineering school in America to not only open applications to women, but to actively recruit women. So I think the gap is closed substantially. Even when I was in school, like I think my freshman class was, I want to say, 10-15% women, but when I graduated, the new freshman class was about 25 to 30% women. But I just don't think those demographics have made it into hobbyist stuff. I think the rubber hits the road here because social interaction and coordination is hard, and I think when it comes to personal projects, a lot of folks just don't want to deal with it. I think, all right, I think we're good here. I think we can get back to routing. I think a lot of folks, like, you know, when you're coding for fun, did we just forget to connect this one here? I think a lot of folks, like, you know, if you're coding for fun or something, you don't want to, oh, what did I do? You don't necessarily want to work with someone all the time. Show. Again, people do, right? Like, oh, lucky. Oh, check that out. I opened up a trace for myself. Righteous. No, again, like, there are plenty of people who work with, you know, do open source projects and work on community projects, but there's no way that's the majority. No way. There's no way that's the majority. And I just think certain demographics are really lonely. Did I route two of these in the same way? What's going on here? Did I route two of these going to the same place? Yeah, this schematic is getting confusing. This is, this right here is why I feel qualified. This is why I talk about this in the first place, right? This right here. Because, like, I personally, like, I've done hundreds of projects. Hundreds. Like, the rate at which I make projects, like, I have no good way of really, I've tried to calculate this. I have no good way of doing it. The back of the envelope is that I'm completing, not doing. I'm finishing a project about. Did I forget one here? Yeah, did I forget one? Oh, we're good. I'm completing a project about every month, or somewhere between every 1 and 3 months. And there's no way I could do that if I'm talking to people all the time. Like, even here, like, you see how much trouble I'm having just, Jesus Christ. You see how much trouble I'm having just, like, doing a basic circuit board routing while talking to someone. Or while talking to no one, right? Like, I could literally just stop talking at any point and ignore you. But just knowing that people are watching and judging and having to think of what to say next and constantly reevaluate my body language, how I'm thinking, what I'm saying, to make sure that I don't do something that'll punish me for the rest of my life is really hard. And I have a hard time believing that that is the ideal circumstances to get the best work out of a team of engineers. I think a lot of this stuff is what they call deep thought. It's deep thought. Basically, like, it benefits from thinking for hours and hours on end, instead of, like, putting in a half hour here, a half hour there, yada, yada, yada. And I think that effect is very strong in a lot of engineering tasks. Again, like, it's also not a moral judgment. Like, you know, folks can do whatever they want. But the point I was making is that this caused a tremendous stir on Twitter, and it seems like I'm causing the same stir in our comment, in our chat, which is great because it boosts engagement and gets more people to watch the video. Yeah, maybe I should back up and read a little bit. Faint Mistral says, if the worst thing you're getting called out on is engineering being a solitary endeavor, then racial angle, you're a lot of steps ahead of the game. I don't, at least here in the States, you can't argue that for whatever reason, the technical practices are strongly skewed in terms of demographics. It's a problem. Like, it's a problem that's been around for a long time. It is improving, but it's not solved yet. It's like more diverse people are getting into engineering, but it's by no means solved. And you know, it's not really a hot take, but I think that I think the idea that engineering, I think the other, yeah, the other part of that, I think it's to some extent it's ideologically loaded. I don't think it's something that whether it's true or not, I don't think people want to believe it's true. Like whether I'm right or not, and I could totally be, a very high chance I'm wrong here. But I don't think people want it to be true. Okay, so we're running into a problem here. We've run out of ran out of room. I don't. Would it help to turn the chip sideways? I think it's I think it'll help to turn the chip sideways. Because then we can route out of the top and bottom. I had a good idea. Again, not every idea works. This also feeds back into why I think engineering personally, why the technical side should stay largely solitary, is because right now I have to backtrack and rework. I would fear for my, with good reason, if there were people watching right now, like, if there was somebody watching me right now who had the ability to, basically, if a coworker was watching me right now, this puts my job at risk. I'm showing that I'm not using company time efficiently. Because I'm backtracking. This allows someone to build a case against me that I'm a bad engineer. And well, I mean, am I a bad engineer? That's not important. The important part is that I'd be worried that I'm a bad engineer, but also that these aren't dice you want to roll with your ability to make money, right? Like you don't want to play, if you can avoid it, like you don't want to play games like this with your livelihood. So we have to reverse these around again. I think I missed a few. Let me think here. So yeah, we'd have to reverse these again. So yeah, if someone was watching this whole time, like, or if a coworker was watching, people are watching, right? But you don't have any incentive to get me fired. You have an incentive. All right, you have an incentive to make. You have an incentive to now, like, for instance, go on Twitter, right, or something, and claim that like, oh, this Zack guy is a fraud. He can't even like route a basic board. Which, all right, fine, but they don't have a direct line to, like, you don't have a direct line to YouTube or anything. Like, worst thing you could do is put a comment on my Patreon or something that makes people like reconsider. So let's see. So how do we want to do this now? Well, we have trace names here, so let's just do it like that. Route N. I wish this didn't have dollar signs. I wish it was just called N53. Oh, it's not gonna work. Let's see. Net N. That's not gonna work either. Will it? No. N53. Yeah, it's just a level of stress that I don't think it's beneficial. I don't think it makes the company stronger. I don't think it makes the team stronger. Is this how we want to do this? Or do we want to yeah, we're only going this far. Let me think here. Did we forget one? Yeah, we just didn't get to it. Ablative Kitten says, see, it's going well. Thanks a lot for the super chat. I really appreciate it. Yeah. Let's see, group. There we go. Yeah. And whether or not that's true, whether or not it's true that, like, it's actually putting anyone's job at risk is, it's not really relevant, right? Like, it's the perception that's making you do worse work. Oh, come on. Like, yeah, one of the hardest parts of doing YouTube videos and streams, for instance, is just reminding yourself that, like, you're never going to be good enough to, basically, like, you're never going to be good enough to, like, avoid avoid criticism. Like no one, yeah, I don't know. I'm kind of meandering in circles here. I never even got to the why I think this affects and I only touched on why this affects hobbyists more than, or what the demographic angle of this is. But yeah. Anyways, this I'm surprised how controversial this was. I guess that's kind of what got me thinking about this. Because to me, like, it doesn't like sure it seems like it could be contentious, but but like yeah. So the question is, I'm sorry I missed your chat, but like someone points out if someone was looking over my if someone was looking over my shoulder, like if we were doing pair programming here, wouldn't someone have pointed that out? Yes, someone would have said like, hey, I don't think you're gonna be able to fit all those traces. But they would have also pointed out a lot of other things that I had actually thought through, or that were irrelevant, or that were unrelated to the task at hand. Maybe they start talking about their kid, and I'm like, well, hey buddy, like I'm trying to focus on working here because I really want to get this thing done before the end of the session. But like I have to pretend to care about your kid because they're your kid. So yeah, and that's that. Note how that is thinking not about routing circuit boards, but not about routing circuit boards, but about unrelated crap. And okay, yeah, like sure, we live in a society, but really, like there's never a time, never, for people to just buckle down and get stuff done. Really, come on. All right, enough ranting about this. I think this could merit a video though. I think it's an interesting enough topic, and I'm really. Let's see. Is this what we want here? I think it would be interesting to explore this after after putting in a week of preparation. Yep, looks like that's our boy. After spending a week thinking about it and researching it and all that stuff, I think it would be an interesting topic to explore. Especially as it relates to DIY electronics, which, stay in your lane, Zach. Yeah, this is my lane. It's the same work whether you're doing it for money or not. All right, so let's get rid of these. Oh, not route, net. I've made this mistake tons of times. I think anyone who's watching me would be a little more like, oh my god, if this guy types net instead of route one more time, I am going to chew his head off with my teeth. So where's N46? Is that this one? Yep. But it's not even about pair programming angle. Like I think the work just lends itself better to barricading yourself in a room for a couple. And I'm not saying like when I say it's solitary, I don't mean like go away for a month and come back with a finished project. I mean like you have your team meeting in the morning, you break, you work for 3 hours, you meet again and compare notes, you work for another 3 hours, you go home. Like I don't mean like you're working in complete solitude. Like, I don't mean like the whole project is made in complete solitude. I mean like you just leave each other alone for a few hours so you can focus on the technical intricacies, all that good stuff. I also have a very hard time believing, like, again, this is a pure factual, like, this is pure factual. Like, my opinion on this will change the millisecond I see some quality data. But I'm very skeptical that pair programming is more productive than having two people work on the project separately. I have a really hard time believing that it's a superior way to go about making a piece of software. But again, like there are companies that do it. I'm skeptical. What can I say? I'm a skeptical dude. Oh, I made a curvy trace. I also think even if it works, right? Even if it does match the productivity of people working separately, I think isn't that going to create massive selection pressure towards people who have just the ability to talk and work at the same time, which, like, isn't a skill that correlates to better programming. Like I just feel like it's I'd also put a weird selection pressure on your staffing requirements. Let's see. And again, this is this is a point of fact, right? There's no opinion. Like there's no opinion element to this. Like this is something that corresponds to data. And my opinion would be, as a rational person, my opinion would be obligated. I would be obligated to change my opinion when presented with data showing, credible data showing that pair programming is more productive. And I suppose it comes down to defining what productivity is as well. All right, fine. I think that's what's a way of saying it. It's almost a matter for the practice of usability. But yeah. All right. Is this a hole cut in the board? No, this isn't. This isn't a hole. These are holes. Let me. You know what? Why am I even bothering to think about this? Let's just turn on the drills and holes. Boop. There we go. Not a hole. So this can be just a straight shot. Yeah, then create some weird selection pressure. What's the name of the what's the name of the company that only does pair programming? They made all of the Palm Pre software. What the hell's the name of that? What the hell's the name of that company? Crap! It starts with a P, I think. The name has nothing to do with pair programming. Yeah, I have never I applied to work there at a job fair back in the day, and I've never been turned down for anything faster and more aggressively than that company turned me down to work for them. So at the very least, I think their HR department is good at finding people who would work well in the environment. Let's see. Can we go this way, or is it going to cause too much? It's going to cause a pile up here. I think we'll just go like this. So we're going to go across here and up. It's going to be a bit of a squeeze, fitting everything in here. But yeah, I mean, pair programming. All right, I guess this is interesting because now that I think about it, there's a point here, right? There's an argument that I never made on the bird site, and that is okay, folks, if you truly believe that engineering is inherently collaborative and should be collaborative, then is our current paradigm wrong? Right now, the paradigm is mostly meet up to plan, right? Meet up to plan, set specs, make APIs and other interactions. Basically, meet up to figure out how the various parts are gonna work together, and then break into solitary. Go figure out how everything's gonna work together. Go back to your office and implement it. So if people really believe that collaboration, really believe this strongly in engineering as a collaborative discipline, does that mean that we should be moving towards an all pair programming paradigm? Are we leaving potential on the table? Is this too close? Is it? We can always move them around. I feel like if you truly believe that engineering is and should be collaborative, then you should also believe that all technical work should be effectively pair programming, right? Because if it's a better way to work, then the rational decision is that's how you should work, right? I mean, the objective of pulling an engineering team together is, at the end of the day, to do engineering, right? We're not pulling these groups together to hang out and play foosball at the company foosball table. You're pulling these people together to build stuff. So if it produces a stronger product, then you must believe that we want more collaboration. And I think to an extent, I suppose this is something that people actually Oh, that one's a little too close. I guess to an extent, this is something that people actually endorse because the Open Plan Office took off for a while. But the Open Plan Office was definitively shown to drop productivity, not raise it. So I'm not. Yeah. So at least on that front, I remain unconvinced. Yeah, I'm a little unconvinced. Let's pull. Let's take a look. It's a Droshna Giore says the same work whether you're doing it for money or not. Sadly, doing it for the love of it probably leads to better results rather than good enough to save money, at least in the U.S. I know I'm supposed to. I know I'm supposed to yes and. I don't think I agree. I don't think I agree. I think there are a number of ways this plays out, but pay has not. There's never been the correlation between pay and quality of work is it exists, but it's limited. It only holds under certain circumstances. Basically, people perform better as you pay them more. People perform better as you pay them more up to a point. It hits a point of rapidly diminishing returns after the person no longer needs to worry. After the person A no longer is worried about paying their bills, and B, if they think they're making the same or more as the people around them. Past that point, extra money is an incentive. The second is, do you get better work? So you have the concept of intrinsic versus extrinsic motivations, which has been, I think that's Sacha Baron Cohen's dad. I think that's, I think he's like the behavioral psychologist who studied that. Anyways, you can motivate people by stuff like money, right? And you can also motivate people with just straight love of the game. Like some people will program whether you pay them or not. Couple things. First off, it's a fallacy to assume that holds true for everyone, because it certainly does not. There are plenty of people who perform better with an extrinsic motivator like money. It doesn't have to be money. It can be fame. It can be fame. It can be recognition. All that good stuff. But there are definitely people who are not primarily motivated extrinsically. And as far as I know, the quality of the work isn't any better. The second thing is that just because someone is being extrinsically motivated doesn't mean they can't be intrinsically motivated as well. Somebody can be paid for programming and still like programming. I think this is something... Now, granted, a lot of people have a hard time with this. A lot of folks have a hard time... Like, I feel like once you get paid for something, you get this kind of mentality where you're like, oh, this is a little too far over. I'm gonna drop this here, and then... One sec. I'm going to group up the tactile switches and move them over, because... let's just move this up. Move this over. Let's see. Nothing stops you from having both. I think this is a skill that people will develop over time. It's something that's not very common now. Basically, the ability to be both, the ability to ignore the extrinsic motivations. Right? Like, I think it's something that a lot of folks struggle with, because. If what's the way of saying it? Like, if you're Steve Wozniak, I think, is like one of the best. He's one of the best examples of keeping this in mind. Like, he could have made a humongous amount of money and gained a tremendous amount of power by following Steve Jobs to the boardroom, but he didn't. He was willing to forgo that in order to stay in the workshop. Is it a smart decision? I mean, I think that goes on a person by person basis. Let's see. Do we have 0.5? Yes, we do. There we go. Let's push on. He's getting too close together. I don't like the way this is going here. I'm going to rip this up and reroute. I'm going to rip this part up and reroute it. Yeah, deliberately for knowing what level you want to be in. Here in the States, the way we pay people, the way companies pay their employees, does not work very well with this. We use what we try to call how do oh wait, now we just rip up the trailing bit. Jeez. We try to pay people based on what we think of as like the complexity of the job, right? With the difficulty of the job. In a place like Japan, Japan's the most. This is practiced very widely there. They have seniority-based pay. So regardless of what job you do, your pay depends strictly on the number of years you've worked at the company. And on paper, this sounds really dumb, right? Like on paper, this sounds like wait, you're just like you do literally nothing. Like you get more complacent over time and you get paid more. Well, all right. Well, table that for a second. Remember that it also means that if you really love your job, you don't have to get if you really love your job, you don't have to get promoted to keep paying your bills, right? Like you don't have a pressure to make more money every year, or rather, you still have the pressure to make more money every year because inflation and whatnot, but you don't have to move through the ranks to do that. Like you end up with employees working the roles they're best at, instead of climbing the ladder to a place where they're out of their depth. To in order for their pay to keep pace with their rent, and I think that's really clever. I was initially not. What's going on here? Why is this not snapping to the smaller grid? Oh, because we're using the same grid for both. Oh, that was smart. Yeah, originally I wasn't really sold on this, but the more I thought about it, the more I like it. It would be really nice if we started doing something similar here in the States. Because I think there are a lot of people who get employed at a job they love, but they end up getting promoted into a role that they don't like because of monetary pressure. At the end of the day, you want each employee doing the job they're best at. It doesn't help anyone to have an employee who is doing a job they're not qualified for or is bad at. Especially if they've another thing to remember is that how long you've been at a company has power in and of itself. So it's really hard to get rid of an underperforming employee. No matter which system you do, it's really hard to get rid of an underperforming employee. And the threat of being fired is not always enough motivation to get to pull the best work out of someone. So let's see. Yes, this has been Business School with Voidstar Lab. I actually did want to put more. My original idea was actually to have more videos about the business of making technology, because that's what I studied in school. But people want the projects. I think it's as for the collaboration. Arrow Raider says, I see no issue in telling them you don't care about hearing about their kid. Have you actually tried that in a professional setting? Because that's a really good way to get a bad performance review written about you. There's certain topics that are sacred. You just have to go every time someone talks about them, whether you care or not. Dogs, pets to an extent. I think it's more acceptable to say you don't care about someone's cat than dog. Pets, kids, cars. If you're a guy, you have to care about people's cars. It's a legal requirement. Whatever sports team is in the city you're in. For instance, here in Denver, you do not say anything negative, or you don't say anything neutral about the Broncos, unless you just don't. You just don't. I'm being more than a little facetious here. I just realized something. I don't need to route Oh my god, I'm so stupid. I've been routing these traces around. I keep pointing at the screen. I've been routing traces around this switch, but that's not necessary because the switch is on the top side of the board and the wire's on the bottom. Let's see, what else? If someone's hungover, you have to if someone's hungover, right? The correct at work and they complain about it, right? The rational response is, well, you deserve, you brought this on yourself. You could have just not, like you could just not drink enough to get a hangover. But you can't say that. You have to be sympathetic. It's the rules of the road. The weather, the weather. The weather has its own weather's its own reason though. You have to be okay with talking about the weather because it's the topic that people bring up when they don't have anything better to talk about. And yeah, it's a topic people bring up when they don't have anything better to talk about. So if you say, "Oh, buddy, I know it's supposed to rain later today. Shut the heck up, you dumb idiot." You're basically telling them like you are a bad small talker. And that's not nice because here in American business culture, it's positive vibes only, baby. Or good vibes only? I don't know. I don't know the meme. I think that's like a vlogger thing. I don't know. Anyways, TKM Case, thanks a lot for the super chat. Why is there a social game inside my engineering job? Well, oh boy, yeah. This is where I feel like, this is where I could have gone on the Twitter discourse I was talking about if I really wanted to light a firecracker under this thing's ass. That is, no matter what, wherever you get two people together, it's a social game. And if you don't want people to be playing games in that context, you gotta keep them apart. Whenever there are multiple people together, it's always a social game. And sometimes, I think most of the time it's a good thing. Don't get me wrong here. I'm not a misanthropist. That's a hard word to pronounce. Like, I'm not a misanthrope, right? Like I think this, having a coherent society is good, right? Don't get me wrong here. But there are some times when you just want to knuckle down and focus. You don't want to play the game. You got something else to do. But it's not an option. We have decided as a society that you're not allowed to switch it off. You have to be, whenever you're around other people, you're always on. And sometimes you can't, you have to provide a reason for people to say, "Hey, come on, man, I don't want to talk right now. I got some stuff to do." It's almost a pretense. It gives people the right to say, "Please leave me alone. I'm on a tight deadline here. I really want to get out of here on time today so I can go home and see my kid." If you really wanted to get home and see your kid earlier, you'd move closer to work, wouldn't you? That was facetious. I am of course joking. I understand that there are a lot more dynamics that dictate where someone moves. Oh man. Oh, Twitter. I don't know where else I would go to get smart, well thought through discourse from people who genuinely care about the issues. All right, so next up we've got these here. So I'm thinking we just route these guys, right? The next two rows, we route them on the top. We route them to pins on the top. That way we don't have any baloney. We don't have any crap. The question is, how are we going to insert them into? Sorry about that. Question is, how are we going to route them over? All right, here's what we're going to do. First thing, we're going to turn all these sideways. Why didn't that turn cleanly sideways? There we go. we're to turn all the tactile switches sideways. And the reason we're doing this is because it will open up more room to route the traces on the it'll open up more room to route traces on the top, because we're gonna need all the space. Basically, like we might have to carry some of this over to the top. Pair toileting, Marty's right. That's it. Oh man, Flamestroyer Shadowkill asks the important questions. When are you gonna make a full moving armored core? I've wanted to make a mech. Let's see. I've wanted to make a mech like some sort of cockpit forever. I have a Steel Battalion controller somewhere here, and it's like a giant. It's an Xbox game, right? Came with a controller. Xbox game where you pilot a giant mech. Came with a controller that's like 4 feet wide. 4 feet. The thing is enormous, and pedals too. It's not just this giant controller; it has pedals, and like it's crazy. Let's take a little break. Let's take a little break while I burn my brain out coding. Hang on a second. I'm swallowing. Oh wait, today's episode sponsored by Next PCB. Use the link in the description to get 30% off. Get your first boards free. Anyways, let's take a look at this thing. Image. Steel Battalion controller. Look at this friggin' controller. Look at this controller. My controller is actually cooler than this one. This one is the picture on this page. Here we go. Check that out. This picture, the Steel Battalion controller, is the second generation. You can tell because the buttons are green. I have the first generation with the buttons. Their buttons are blue. Look at this. Look at this crazy thing. And it's got foot pedals. This game rules. And the game sucks, but the controller rules. Good stuff. Good stuff. It's so cool. Oh man, so I've wanted to build something like this forever. Where exactly you put this controller is really see this wasn't very well thought through as a product, because where you put the controller, like you can't put it on, like most people don't hook their Xbox, like you can't put it on a desk, right? Because who hooks their Xbox up to their monitor? Like back in the day, don't forget, the Xbox didn't have any output that connected to a monitor, right? You couldn't just wire it up with HDMI and go for it. This was an OG Xbox. You couldn't put this thing on a coffee table either, right? Because like if it was just the sticks, you just put that in the coffee table, sit at the coffee table, and there you go. But it has pedals. You can't put it on the coffee table. So you have to move a table into your TV room to set the Steel Battalion controller. And this the Steel Battalion is also very old. This is important. I said Xbox, and I don't mean Xbox One. I don't mean Xbox 360. I mean Xbox. This picture was taken in 2008. Let's see. Where's the page that it goes to? Here we go. Steel Battalion. Steel Battalion for the Xbox console, made by Capcom, 2002. Right? Keep that in mind. This game with this crazy controller came out in 2002. Let's put this back on. Oh, there we go. It came out in 2002, all right? Here. I'm typing in Guitar Hero. Guitar Hero was released in 2005, right? How about this one? How about Dance Revolution? Except, wait, Dance Revolution, yeah, let's just look for this. So Dance Dance Revolution came out in 1998, but that's the arcade version. The PS2 version, where's the PS2 version? DDR PS2. Let's see. When did this come out? List of Dance Dance Revolution video games. There we go. All right. So you had DDR in Japan. This is in the 90s. All right, but it didn't come to the States until I think until the PS2. I think so like second mix. Basically, Dance Dance Revolution was also only just coming out. The point I'm trying to make here is that nowadays, if you go to a game store, you see big-ass boxes like Guitar Hero and Rock Band, Dance Dance Revolution, and bongo controllers, and, like, you know, fitness mats and all that crap. The Wii wouldn't release for a while, too. The Wii was 2006, so Wii wouldn't come out. Wii and its accessories wouldn't come out for years. These madmen made a video game that consumed something like 50 times, like they consumed something like 20 times to 50 times more shelf space than a regular game. They could only, like, not only was this game like almost unplayable, but it was a nightmare to convince stores to stock it, because it means they would have to take like 20 other games off their shelf just to fit them. Needless to say, this game was a tremendous bomb, but it is it's so close to my heart. I love this game. It's one of my favorites. Anyways, yeah, we have the controller. It's not a great controller. It's not very high quality. It feels very fragile and breakable. But I still love it, and I would still like to make something I'd still like to make something similar for a future project. Memory lane. Picking them member berries. All right, let's see. So we're going all the way up. So we've gone all the way up to all the way down to pin 8, right? So we're gonna get rid of the rest of these. Nope. Yeah, right? Yeah, we didn't rip anything up. We still have to route these two. Yeah, we still have to route these two. That's important. So throw into bar. Okay, there we go. Oh man, that would be. I keep mixing up route and net. I think they should have just overloaded the command so it does the same thing. We're sending this to pin 7. Pin 8 is accounted for. That's right. Pin 7. There we go. And finally, we're going to bring pin 5 over to our last button, our last switch on the row. I keep calling them buttons because, let's be honest here, they're buttons. They're buttons. Let's clean up the HUD. And let's route this guy. This is what I was saying before. Like, this task is a little tedious, but it's still cold bar. This task is tedious, but it's not. But like we'll be able to make fairly quick progress at this point. All right, we're gonna have to move that one back into position in a few. I'll clean this. We'll clean this all up later. Alrighty. So yeah. Anyways, that's the Zack Freedman hot take. If you notice me like quitting making videos abruptly, or you know, if we start getting swatted a lot, now you know why. Because I said that. Because I went on a bird website and I said that some things are better off being done alone. Now that I think about it, maybe making a sizzling take like that on a social media website, especially one that tries to be largely progressive and saying that sometimes it's good if people don't spend time together. I could see how that would be punished. Alrighty. 80 air wires left, and we haven't even routed all of them. Welcome to circuit board. Welcome to circuit boards. Okay, so we're using up all the space. We're eating up all the space here. So that's fine. All these traces here, let's embiggen this. Embiggen. All these traces here are going to make a turn. They're going to go, and they're going to follow these up. So you can see how we're conserving space by being very judicious about our traces. Also note, we haven't wrote a single trace on the top of the board. We haven't had to. Yeah, we haven't wrote a single trace on the top of the board. We haven't needed to. We've just been careful about what's going on here. What do we not have the budget for? Adam says, Brooke, can you tell Zack to look at the Gundam Battle Pod, as it's a massive upgrade to the battalion controller? Oh no. Oh no. Oh no. Oh no. Oh no. I've played a similar. I haven't played this one in particular, but I have played a game that uses this. I think the same console. I think that uses the same cabinet, as it were. I don't. Yeah, I haven't played this game, but I played a game that uses the same cabinet. It's pretty cool. It uses a projector. It doesn't have a monitor. It has a projector, and it projects onto this curved screen. This one, yes, this one, the Star Wars one. I've played this. I played it at Dave & Buster's a while ago. It was fun. It wasn't worth the $4 or whatever. Man, some of the prices they charge for these to play these arcade games these days is complete insanity. It's yeah. Back in my day, it was just a quarter. Back in my day, we used to have to walk to the arcade uphill both ways. All right. There we go. All right, so we're gonna start here. Oh, Jesus, why is it? Should really overload that. Oh. I don't. There are many stupid things about Eagle. Many stupid things. If I went into talking about everything that's stupid about Eagle, I would have to stop routing this board because it would consume all my working memory, just remembering all of them. Holy crap! There's some aspect. Jesus, some aspects of Eagle I just cannot comprehend how they came out being made that way. Reagan, thanks a lot for the super chat. Much appreciated. He, she, or they says refund for Dave & Buster's. Oh my. I think that a refund for Dave & Buster's. No, not route. It's net. Yeah. Anyways. Oh man, I miss going to arcades. I used to love arcades as a kid. I used to love going to the arcade. Oh man. Let's see, I used to like playing pinball, of course. I mean, every kid loves playing pinball. I think my favorite was what was it called? Deco Art. Thanks a lot for the super chat. Really appreciate it. Much obliged. My favorite was called Theater of Magic. And Theater of Magic, I remember that because it's actually a very well-known table. It's well-known as the table that has probably the easiest multi-balls and the easiest hazards or whatever they're called to activate. And that's, I was a kid. I was bad at games. So of course I'm playing easy mode pinball. That was a cool table. I had a chance to play that again at Modern Pinball in New York City. For a while, there was a pinball arcade. Did I rip up traces and just put them right back where they used to be? Or did I just... Wait a second. Did I rip up traces I had already routed? I totally did. Oh man, I'm really dumb. It's a good thing we have Control Z. Oh, you want to know how ahead of the game these folks are? Here, check this out. Boop, boop. I said boop. Where is it? Oh, how did it end up over there? The folks who made the loop deck put a dedicated undo button on it. That's how on the ball they are. Terry Rostos asks, "Have you tried Dip Trace?" I haven't. I know it's very popular in the industry though. I know it's a popular EDA suite. I don't know much about it though. Let's see. I don't know a tremendous amount about it. So we're starting at 37. All right. Damn it. All right. Well, at least we're almost done with the switches. We're on the last row. What did we we're on the last row. Although I'm sure we'll discover something that we've done wrong. This is Voidstar Lab. I'm sure one day we'll... Every once in a while, something works. Every once in a while, I just finish something. I don't make any major mistakes. I don't have to undo anything. Nothing explodes. And then I spend an hour debugging it anyways, because, I'm convinced I just haven't found the problem yet. It's part of the process. When you're building hardware, everything is the enemy. everything. Everything is the enemy when you're building hardware. Everything from moisture in the atmosphere to like everything from moisture in the atmosphere to you routing two traces across crossing each other. Everything can screw you up. So yeah. So the way the joke goes is the user blames the software guy. The user blames the programmer. The programmer blames the hardware guy, and the hardware guy also blames the hardware guy. And as somebody who's built a lot of hardware, yeah, screw the hardware guy. That guy doesn't. How does he even get this job? That guy doesn't know what the hell he's doing. I haven't tried dip trace. I know it's fairly popular in industrial settings. It has a distinct what is it? It has a distinct way that It has a distinct way that it calls out people on Twitter. No, it has a distinct way it calls out like references, like things that are wired up, but like things that are connected but not wired together on the schematic. It has a very distinct way of signifying that. And once you recognize it, you'll see it everywhere. I mean, I looked into it when I realized that Eagle is kind of a pain in the ass, and I ended up settling on Altium, but I tested diptrace, OrCAD, and Altium, and I don't know, just didn't strike me as much more usable than Eagle. A lot of these enterprise EDA programs have features that I wouldn't use, like stuff to like enable boards to be synchronized, like to enable multiple people to work on different parts of the same project. And of course, I'm not going to use that. It was also a little calculated in that I think of all the industrial EDA programs, I think Altium has the highest chance of becoming maker friendly. They've toyed in the past with I think they made like a version for makers that's not like, it's not as full featured as it should be. I don't remember the downside. The downside is significant. They toyed with that, but I think one day they will get their heads out of their behinds and make a version that is hopefully free, but otherwise is affordable. Yeah. Pardon, Altium. We're currently using Eagle. One thing I didn't like about diptrace is that I found it very difficult to make components in it. Altium's workflow for making new components is great. It's excellent. You can make new components, including the 3D models, in like seconds. In Eagle, it's a giant pain in the ass. You basically have to make a new drawing. You have to make a drawing. You gotta make a drawing. You gotta model the thing by hand. In Eagle, there's no way to like quickly add in like a dip 14. You have to copy it from another part. You gotta link everything together. You gotta label it. You have to, if there's a 3D model attached to it, you have to model that in a different program and put it in. It's just a big thing. In Altium, it's super easy. It has like generators for all wizards and generators for all kinds of stuff, and you can like put down a tray. You can put down a pad and say like, I want 6 more of these, and I want them spaced a half millimeter apart. Let's see. Yeah, that's all these switches. Let's save before something else goes wrong. And am I missing any? No. Let's route the micro switches. So, somebody, I'm sorry I'm sorry I didn't remember your name or answer this faster. But someone asked, what's up with the micro switches? Why not just use key switches? These micro switches are, so we're gonna put these. We're gonna put these guys here. Let's boop. We're gonna put these 128 by 32 OLEDs. We're gonna put 6 of them on the side, and you see how they're only supported on one end? Well, we're gonna put the push button under the other end, turning these into buttons with screens on them. I did not invent this. I'm not that clever. I will look up who made it because they definitely deserve credit for having such a large brain. I didn't come up with this. I'm not that smart, but it's cool as heck. KiCad does do 3D. Alexi is correct. KiCad does 3D. It's now a first-class feature, which is nice. Being able to get 3D models of your boards saves a bunch of time. Although, I mean, that's let's not poop ourselves here. It's not that time consuming to just export a screenshot of your board into Fusion, right, and just add in boxes for the tallest components. You're generally not fitting a circuit board into an enclosure that tightly that you need to model every component. It's just the important ones. But yeah, all right. So let's route the bottom one here. Geez, I keep mixing up route and net, and this. It's not because I'm flustered. I've literally been mixing up the route command and the net command for my entire career. More or less, the entire thing. Man, I just want them to get rid of the I just wish they didn't make the module command, because then I can't type M in the command line to invoke the move. Because it sorts them by alphabetical order and module is ahead of it. So now I have to type MOV, and damn it, damn it, Eagle guy, I want those microseconds of my life back. There we go, everything's hooked up. Woo, ayo. Very nice. All right. So we got 6 of these bastards. Here's the question. Oh my god, I'm so dumb. I was going to say, here's the question, what processor are we going to use? Because we're really racking our brains on this. I just realized there's one microcontroller out there that has the advantages of A, having a ton of I2C buses. 2, apparently I've been told I missed the top left. What did I miss? Hang on a second. Top left. What did I miss? Let me see. Let's show this. The top left button's right here. Yeah, I didn't miss anything. This is 2 boards, remember. We're not connecting every single button to this. Yeah, we're not connecting every single button. We're just connecting many of them. Let's see. Oh, right. Yeah, there's one board that has a whole bunch of I2C buses, and it's cheap, and it's got name recognition. Yeah, it's Pi Pico. This is a perfect opportunity to use a Pi Pico. No, unfortunately, yeah, Reagan says, please God, not TNC. Yeah, please God, not TNC. No, this is not appropriate for TNC. Carl Fetterman, thanks a lot for the super chat. I'll get to you in 1 second. This isn't appropriate for TNC because the TNC bootloader is... You can only get the bootloader pre-programmed onto a chip that Paul himself sells. And that makes this inappropriate for... either a mass-manufactured project or a mass-reproduced project. The first, because it's not practical because it would be very expensive for me to order a bunch of these things to kit them out if I'm selling this thing. And the second, because it means that makers can no longer buy 100% of the components from the same place. Yeah, I did check that. I think I'm like 90% sure that DigiKey sells Kale low-profile switches, and every extra step, including buying things from multiple places that you require people to do, massively drops the chances that they do it. You always want to have, whenever you want someone to do something, whenever you want people in general to do something, you have to have the fewest number of steps. Every single step, no matter how trivial it is, makes a difference. Like it makes it really reduces people sticking to it. For instance, that's why I don't do YouTube memberships, right? Nothing stopped. Like I could do YouTube memberships and Patreon, right? I can just shout them all out together. but I don't want people to have to decide between YouTube membership and Patreon. I don't want people to have to think about that. I want people to just say, hey, I want to support Zack. Oh, hey, Patreon. I don't want people to have to think, because that's a step. There's a whole book about this, in fact, called Don't Make Me Think. Great design book. You should totally read it. Carl Fetterman, thank you so much for your super chat. Sorry for taking so long to get to this. Carl says, keyboard channeling your Discord when? I'm thinking about it. Let's see. I'm thinking about it. It's on the list. Basically, right, so for anyone who hasn't been to our Discord in a while, I added a bunch of special topic channels. We have one on Linux. We have one on real hacking, like security penetration. We got one, I added one on makeup and effects just for fun. We got one on content creation. And what's the last one? I forget. Anyways, what I'm going to do here is every 2 weeks, I'm going to check each of these channels. And if the average of posts per day, let's see, basically if the average of posts per day is below 10, I'm going to delete it and replace it with something else. So every 2 weeks, we're going to check the analytics on that and wipe any of them that aren't active enough. On top of that, this is a rough this is like very rough, but if one of those channels goes somewhere in the neighborhood of 3 days without a single person posting to it, I'll probably just cut to the chase and wipe it out right away. Yeah. Yeah, sorry for taking so long to get to your super chat, Carl. I appreciate the support tremendously. It makes a huge difference. Every little bit helps. All right. So let's route. Alrighty. So because Eagle is so intuitive and so well designed, we're going to route traces from the top to bottom, but we don't want to run the route command yet. We want to start with the via command, because look how disgusting this friggin' via is. Look how friggin' gross this thing is. Look at that. Oh, it's huge. It's huge and it's square. Why would you do that? You don't need the corners on the via. No, I like octagons, and I like the smallest drill in the rack, 0.5 millimeter. Every PCB manufacturer has a 0.5 millimeter drill. Every one of them. So now that we've selected our via, we're not going to use it. We're going to go back to routing, and now when we switch from the top to the bottom, it will automatically place that via that we selected. What is a via, you may ask? A via is a via is like a wire that connects the top half of the board to the bottom. Note how or the top side of the board to the bottom. Note how I am routing this. I am not just jumping to the top layer and making a beeline to the switch, because it's very important that we stay methodical here. I want everything on the bottom layer, only for with certain exceptions, like these diagonals here. Everything on the bottom layer goes left to right, right to left. Everything on the top layer goes top to bottom, bottom to top. It is really hard to get an auto router to. It's really hard to get an auto router to do that properly. I hit middle click to automatically via to the top. You'll notice the via gets placed when I connect this. Check this out. Boop. There we go. This sharp turn here. You're not supposed to put sharp. You're not supposed to put sharp turns from the top of the board to the bottom. If the signal, if the trace is carrying a high frequency signal on it, because it'll act like an antenna. For a button, it doesn't matter. Make it curve as aggressively as you want. Nothing bad will happen. I don't know why it's called a via. I don't know why they're called vias. Paul McDonald guesses that it's a viaduct, perhaps. Also, whether it's pronounced via or via is surprisingly controversial, and that amuses me greatly, because that's a perfect thing for nerds to argue about. All right, so here's what I'm gonna do. I'm gonna rip this up, because this is no, not all the way. This isn't the cleanest way to go about this. Here, we're gonna rip this up too. We're gonna move this guy up here. This is why I like, that's why I like the octagon, right? Because if this thing was a square, change shape, square, boop. Look how close that is. That means we, like, there's no reason to use square vias. Why use octagons instead of round vias, you may ask? I don't know. I just like octagons. The for the because I route at 45-degree angles, there's no difference between an octagonal via and a circular via. How do we want to do this? So let's see, that's going to go here, and this is going to go around the outside, around the outside, around the outside. Will that work? No, we're going to go like, if we route this to here, then we're going to have to route this to here. I guess we could drop the via there. It's just not as clean as it could be. All right, whatever. It's really easy to get caught up trying to make a really nice looking board, but it doesn't matter how it looks, it matters how it works. That's not true. You know what? That's not true. This is a mechanical keyboard. I've been floating the idea of selling this thing, and if you want to sell a mechanical keyboard, every aspect of it, down to the circuit board, has got to look mwah, chef's kiss. Mwah, mwah, mwah. Yes, into the Christopher says, "Oh yeah, brother, into the octagon." Yep, they're like little tiny squared circles, like little tiny wrestling rings where electrons can duke it out. 2 electrons enter, 1 electron leaves. That was an XKCD. That was a rather amusing XKCD. One of the pipe dream projects that I would love to make, but forget do I have time to do it. I don't even know if it's physically possible. Is the I don't even know if the thing is friggin' possible. It's the keyboard from XKCD. Look up XKCD keyboard. That's a great one. That's a great XKCD. All right, I'm going to. All right, we got a problem with this model. All right, so it's telling me to route this to this particular pad, and I'll tell you why that is. We're going to open the device, not the package, and that's because whoever designed this, A to fruit, tisk, 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 they didn't internally connect the pads. Here, check. Not sure if you can read this, but it says this one goes to A, this one goes to A prime, this one goes to B, this one goes to B prime. This is not an accurate way of representing this part. We're going to disconnect A prime, we're going to disconnect B prime. That's because, let's see, pin A prime and pin A are internally connected. It is not only is it incorrect to break them out separately on the board, it's valueless. It doesn't do anything. So these are internally connected. So I change that. We save the library. Now watch this. I'm going to type update semicolon to update all of our libraries. This unconnected pin. Oh, hang on. I forgot about that. So I don't. It's not necessary to. Here, we're gonna edit the symbol, and which one is this? Pin S1. These are not S. It's not connected to. All right. Here's what happened. Here? I'm gonna close this without saving. All right. Here's what happened. I forgot that there are two variants in here, so we need to just edit the other variant. Believe it or not, it could be much harder than this. This is one of the things I like about Altium. Append, and we're going to append here. All right, very nice. And now we can edit the symbol. And what? No, it's not. It's not connected to anything. What's it connected to? The heck is going on here? It's not. Oh, is this used in a different? Are they doing this to reuse this? No, No, friggin' Adafruit, no. There is literally no micro switch out there. There's no dual pull, dual throw micro switches. It's not how this works. There might be a dual pull, dual throw micro switch. That's probably a thing that exists. Yeah, I overstepped here. Hang on a second. Let's see, rat. I think did I do this backwards? Man, I'm gonna remind everyone that it's been a long time since I have edited boards. I've been doing let's see, the pins are, yeah, these don't need to be, why is this giving me a hard time? These don't need to be connected. You can have do nothing pins. P1 pad A prime. What did I mess up here? How did I do this? I've done this tons of times. Yeah, these are all connected. You can have logical pins that do nothing. The pins are which one? The pins are the physical device. The pins are the are on the schematic, and the pads are on the pins are on the schematic, and the pads are on the the pads are in the footprint. Oh, I'm confused. What's going on here? We could totally have multiple pads that are internally. You can have multiple pins that are internally connected. Like, that can. I am confused. Reagan says, as part of the hive mind, what's the problem? Problem is it's giving me this cryptic error message that it's saying that the parts and the device is invalid. It's got update. It's saying that the thing is invalid because package variant -EVQQ2 in the new version of SPSP TACT has an unconnected pin G1 to S1. And that shouldn't matter. G1 S1. Yeah, it shouldn't matter that it's unconnected. Or I should be able to connect the pins internally. Maybe if I hang on a second. Which one of these is S and which one's P? A prime, B prime. I guess it doesn't matter as long as they're consistent, right? Yeah, let's get back in here and connect. Sorry for this. I probably shouldn't have messed with it. P goes to A, S goes to B. P goes to A, S goes to B. So there should be a way to. I'm sure there's a way to mark these internally connected. Right? I'm sure of this. I feel like I've done this before. Like, I've done this before like dozens of times. But I'm not gonna do this live in front of our live studio audience. First, let's save before anything else goes wrong. Let's check the symbol. I'm sure there's is it swap? I think it's the swap level. I think it's the swap level. Swap level 1, level 1. So it's marking these pins can be swapped, but it's not saying that they're not saying they're internally connected. I forget. All right, don't worry about it. Not important. See, the reason this is a pain in the ass, right, is because this trace here is going up to the top, basically the top pad of this, even though these two here are internally connected. And there's no reason to do this because all it does is cost more space from our board. So connecting it to here is functionally identical to connecting it to here. Here's the problem. If I just say, oh, I'm just going to net, I'm just going to connect here to here. Problem solved. Haha. Well, then now wires have to be, Yeah, here, check that out. I had this backwards, but you get the idea. See, now there's an air wire between them. Now the board, now the DRC is going to bug me. These wires aren't that these pads aren't connected, even though they don't need to be connected because they're internally connected. It's a big pain in the butt. So yeah, does this change anything? Hang on a second. Does this change anything if we could move this to here? No. Does it change anything? Could move this to here? Not really. Does this change anything up here? No, we can't because we can't overlap. Daryl says, Zach, is it possible to user the PCB from a rubber dome keyboard to make a mechanical keyboard? If the question starts, is it possible? The answer is generally yes. Is it a good idea? Absolutely not. That is not a good idea. No, it's not a good idea. Basically what it's not a good idea. Basically the way the two keyboards work is hang on a second. Let me just get myself teed up to start looking at this. Very nice. All right, so here we're going to delete this. So the reason why is because rubber dome keyboards, there we go. Yep, rubber dome keyboards. If you look at them, there's like these. If you look at the board, there are these two interlocking. They look like this pretty much, but they're very close, but they're not touching, and they're black. They're not metal. That's because those are carbon covered. So what happens is when the key has a little pellet of conductive graphite, a little pad of rubber impregnated with conductive graphite, and when the key goes down, it bridges those. Carbon is very conductive and doesn't tarnish or anything. So first challenge is. Wait, I'm confused. What did I mess up here? Why isn't this connected? Show this. Oh, am I? Oh, it's the wrong one. Yep, I messed with the wrong one. Ay, Gewalt. Oh, I'm hitting undo with the wrong thing selected, I think. Oh, Jesus. All right. I routed the wrong thing. Oh my gosh. Okay, so this is going to go to so this trace we want to wait. Which one's this? Show. The show command. Oh, why is I changed the sensitivity of my mouse and the little pop-up is covering the entire screen. Huh. Awesome. Great software you got there. So the show command shows it on both. This is switch 3. Yeah, so I turned this thing around, and we want to connect it, or wasn't necessary. No, I had this in the right place the first time. All right, oh, geez Louise. I am all kinds of kerfuffled. Okay, so you'd have to scrape all the carbon off and then solder that to some sort of keypad breakout board. And, yeah, on top of that, the way they work is often different. Oftentimes rubber dome keyboards are capacitive. They aren't, so when the dome presses against those contacts, it doesn't create a dead short. Instead, it just decreases the capacitance. And those might misbehave when they're connected to a key switch. Yeah, so it's not worth it. The circuit board and the components that go on the circuit board are such a small proportion of the total cost of the project. I don't think it's, unless your time is literally worthless, I don't think it's worth it. On top of that, remember, you're still going to have to solder the keys to something, right? Like, I guess, all right, fine. I guess you could just, like, scrape the, I mean, well, hang on a second. I was gonna say, I guess you could just scrape the you could scrape the mask off the board and just wire it directly into the matrix. But I don't know if rubber dome keys are matrix the same way as mechanical keys, because again, a lot of them are capacitive. So personally, I would say just spend the 20. Just spend the. Use our sponsor. Use the link in the description to go to Next PCB and spend $5 or whatever to get the circuit boards made. Put the components on. You know, those will cost. Pardon. If it's got diodes, it'll cost you $30. If it doesn't have diodes, it'll cost you $25. And yeah. Loco says, can I connect a mechanical switch to a generic Arduino connector? What is a generic Arduino connector? Do you mean the pins? Like, can you shove the switch into a pin? Like, into the header, I mean? Like, can you shove the switch into the header? I don't think you could do that because the... Let me grab one here. I don't think these are long enough. I don't think these guys are long enough to make their way all the way into a pad. On top of that, they're not lined up on a grid, so you're not going to be able to get both of them into the same Arduino, so I don't think so. Yeah. LQQ out says, is there a ghosting concern too? If you're talking about the... I mean, if you're just replacing rubber dome switches with... with key switches, it'll be the same as the original. With this keyboard I'm building now, there is no possibility of rollover because we're using an I/O expander. The I/O expander can read every key at the same time. In fact, we don't have an option. I think we have to read all of them at the same time. So there is, this is going to have this can have N key rollover, assuming whatever keyboard library we use supports it. If it has software support, it also has hardware support. So yeah, all right, that's all of these wired up. Why isn't the other side should be going to ground though? Oh, we just never connected that. Oh, that'll explain it, right? Net. So the other side of these micro switches we're going to send to ground. So let's just bring them out over here. What do you think? Does it make sense to give each one of these its own ground pin? I think so. I think these all deserve their own ground pin. Boop. Boop. How's this gonna go? We're gonna put this right here. It's kind of awkward. You know what? Yeah, let's move this up. Let's put this here. Just want to see how this looks. Move this over. Copy in our ground. Yes, we do want to rename this. That looks a little wonky, but what can you do about it? So let's move all these guys up. Avoid switching tools. He says, shibbolething like crazy. All right, and then we're going to add our little tiny segment of net here. I don't like directly connecting symbols to each other because it makes them look like the same symbol. I like having at least a little bit of green. What kind of green? Super green, emerald green. Actually, yeah, well, let's connect these guys together too. There's no reason not to have both of them go to ground, except it makes it marginally harder to solder. Fine. There's no reason not to have them both go to ground. It can actually act like an above board, it can act like I was going to say above board via because I'm dumb, but it can act like a jumper to connect the ground together. You want the ground plane, yeah, it's not enough to just like put a ground plane on something. Like, it's not enough to just add a ground plane, right? You have to go to every ground connect. If you're good at your job, you go to every ground connection, and you figure out the exact route. Or if you're diligent at your job, I shouldn't say good. You go to every ground connection, and you figure out what is the exact path this is going to take to go to the ground, like the negative terminal of the battery, or the negative USB or whatever. And you figure out how many times it has to go up and down and around and through choke points. And you get rid of those by adding more vias. If you're a normal person, you just pile a ton of ground vias everywhere and just try to stitch it together as best you can. So we have this the schematic. All right, so this is looking a little... All right, so these are all wired up. I just want to take a look at our board here, because or our schematic, because it's looking a little confusing. So basically, what I'm going to do here is I'm gonna just delete redundant. I'm gonna just delete redundant wires. Let's see. We don't want that one. Yeah, I'm just gonna delete redundant wires because it's very or redundant nets, because this is confusing as heck. Let's see. So that's the real one. We don't need this one. All right. Yeah, just a bit of cleanup. Yeah, look at this. It's so confusing. Yeah, so I'm just running the show command to let's see. Yeah, I'm just running the show command to highlight the entire trace. Actually, this isn't showing up very well in the stream. So I'm just not gonna do this. We're gonna reserve this. Schematic. Some people don't call them schematics. Bye Akalia. Some people don't call them schematics. They call them schemes. I don't know why. It seems to be like a lot of I don't know. It seems like almost to be a geographic thing. They call them schemes, not schematics. M. Peekles. Never mind. He's not talking. He, she, or they is not talking to me, or are not talking to me. I don't know if you self-identify as a collective. Who am I to assume how many people you are? Okay, so we're talking about the RP2040. The RP2040 is a natural choice for this project. But the question is, can we get it in a form that people can actually solder? RP2040. So this is a leadless part. I think this might be a non-starter. Unfortunately, I think this could be a non-starter. Oh, here's an interesting one. Look at that. You got a little castellated Raspberry Pi Pico implementation. That would be a really cool choice for this project. That would be pretty freaking sweet. Pi Moroni has announced 3.0, including minimal implementation. That looks pretty cool. It has a USB-C. You know how much you folks know what I think about. You folks know what I think about USB-C. You know I love USB-C. Let's take a look. Pi Moroni, RP2040. Here's the question. Is this an open source project? Because if I can manufacture my own, if they stop producing this product and I can manufacture my own, I think it'll work fine for this project. If I can't manufacture my own, then it is not appropriate, because Pi Moroni stops selling it, we are screwed. Click here, download the firmware, getting started guide. No, I'm not seeing anything about the source. I don't think this is open hardware. They have an EagleCAD part, but it's not the same. Yeah, so we can't use this, because if Pi Moroni stops selling the product, then I would have to stop here. Are we actually going to sell this thing? I haven't decided yet, but I think it's neat to design this assuming we are, because it's a teachable moment. So it looks like this is a leadless part. So I don't think the RP2040 is appropriate for this project. UC Tronics. Alternately, all right, we could get really into the weeds, and I could make my own version of this little breakout dealio, and it uses that. This is a bit tempting, but that just means more products to design, and it means I would have to manufacture all these. What do you think? Should we make our own Pico Nano for mechanical keyboards? I could make the biggest brain play and make it the same form factor as a Raspberry Pi Nano or Micro? Or no, an Arduino Micro, so it could be a drop-in replacement for other people's keyboards. We could really embiggen our brain. So this right here, I'm talking. By the way, the castellations. I think they're pronounced castellations. It might be castellations. The official Pico has these as well. I don't want to use a Pico itself for a number of reasons. In part because the Pi Foundation could stop selling it at any time. But it's not wholly inappropriate for the project, because you see these little bites taken out of the side here. Those are called castellations, and the purpose of those is that this enables this entire board to be surface mounted. So all you do is you put big oval-shaped traces under each of these. You lay this board on top, and you can get a soldering iron in here into this bit that's plated and solder the board directly onto another board without having to put a header or something to make it taller. You just one right onto the other. Yeah. So that's what those are. They're called castellations. I suppose another question is, can we actually buy Pi Picos? Let's check that first. I checked this a while ago, and it was in stock on DigiKey, but things change, especially now. Eval boards. So there are a lot of different variations of it, and it seems like a few of them are in sale in small quantities. But let's see, they have 2 in stock. Maybe I should buy them while I can. 2 in stock. Maybe, actually, let's go to Octopart. Octopart searches a bunch of, here we go, RP2040. Octopart searches a bunch of suppliers' websites to check all their stock in general, and it also finds related products like it's doing right now. But no, I want the actual RP20. You can't really search for RP2040. You have to search for, where is it? What's the internal name of it? SCO908. SCO908. Otherwise, you'll get dev boards that implement it. No. Raspberry. There we go. Okay, so it's not showing us anything else. RP20. All right, so they're calling it the RP2040. So it's known. It looks like this thing isn't in stock anywhere. This is a problem because this is a popular part. I think this is a poor choice for the project. Even if this thing goes back in stock, there's going to, like, even once they start manufacturing them again, assuming they're not, there's probably a massive pent-up demand. So, yeah, this is going to be a non-starter. We want something else. The next obvious choice is implement the Arduino Nano. Basically, like, add a Leonardo in there. But basically, the Atmega 32U4, which not a bad choice. Let's confirm that that's in stock too. I'm using DigiKey as my first line because I've just found them to be a bit more reliable than Mouser, but it's always worth checking both. Let's see, Atmega 32U4, and we want the microcontroller. So this is available in so this is available in a leaded component. This is they don't have a lot of stock. They only have 100 of them. Let's check Octopart. Atmega 32U4, and we want the one with the pins. It's very important. 32U4 RC. What part of this has the form factor? None of them, really? MU AU. Yeah, this is the 32U4 RC-AU. Sometimes AU means like gold-plated, but that doesn't make any sense here. RC.-AU. All right, let's see what we got. So it looks like Microchip themselves has them in stock. Minimum order quantity is 160, but again, that's a flat. They're sold in flats. I think, actually, no, they're going to be 2 versions. One of them's going to be sold in flats. The other's going to be sold in tape. Tray, they call them. So it looks like the one sold in the tray is available, and the ones sold in reels aren't. This is there's a chip shortage. It's a sketchy situation. 32U4. I think this is going to be our choice. This thing has how many? Let's look up the specs on this thing. Atmega 32U4. Actually, before we get too deep into this, let's see. Jared F says, "Hey Zach, we have the same last name. I want to know if we're cousins. What's your great grandfather's name?" Oh my God, I don't remember. I hope my parents aren't watching this stream. I don't remember. Yeah, I don't remember. Genealogy's never really been one of my interests. Let's see what perifs. See what our perifs are. Perifs. We have one I2C bus. Let's see. Do we want to try something else? Do we want to try something else? What's let me look. So I'm hopefully gonna use QMK. We're gonna take QMK and we're gonna fork QMK, and we're going to create our own matrix driver. Basically, like we'll just write the low-level driver that reads the key matrix and reports which keys are pressed down, and then we'll rely on QMK for the rest of it. I looked into this; it doesn't seem particularly hard. I'm not gonna. Hopefully, I don't have to do it on stream though, because I know how much the world loves watching programming. So QMK supported chips. I know you can technically put it on anything, but you know I'd rather not write my own friggin' make files if I can avoid it. If I'll use Lufa, I'd rather use native USB. 32A, 328P. Oh wait, yeah, Lufa is the built-in one. 32U4. I've never heard of these ones. What's the AT90 USB 64? What's that? High performance, low power. I do like both of those things. 16 MIPS. So we get 2K of EEPROM. We get 64 kilobytes of program memory. That's nice. All right, it's a little better. What about the 128? I assume we get 128 meg. Yep, 128 kilobytes of program memory. Aren't exactly fire breathing. This looks like a low cost part. Again, we don't need a lot of I/O because we're using an I/O expander. But none of these give us more. This one doesn't even have a single I2C bus. Oh my. So yeah, none of these are any better. We can also use any ARM chip with USB that Chibi OS supports. HG Williams says, hey, sorry to be so off topic, but what's your recommendation for beginner oscilloscope? I can't find the video where you mention it. Cheers, bud. I never mentioned it. I don't believe there's a bit. I don't know. I don't know, man. I don't know. I don't think there is a beginner oscilloscope. I don't think you need an oscilloscope until you start getting into some pretty advanced circuits. I think you just need a really nice. You really need a really nice multimeter. Let's get a really high quality meter that'll tell you when things are off, when they're on, when they're changing. You might want to consider a logic analyzer like the Sealy Logic if you find yourself debugging like communication with chips often. But you are if you're at the point where you're ready to, like, you know, watch waveforms of analog signals and figure out, like, where ESD spikes are happening and, you know, debug high-speed protocols and whatnot, like, look for crosstalk, you're committed enough that you can shell out $1,000 for a scope. Like, at that point, if you've made it that far in learning electronics, you're not going anywhere. You're in this for the long haul. You might as well get something decent. My first one was, I got a Rigel 20... something or other, and there was this software that updated it, that unlocked features. Basically, like, it had features locked behind a paywall, and there was this tool that unlocked it. So that was my scope for a while. Is it a violation of the DMCA? Well, it will be an international incident because the company's Taiwanese. But yeah, that's the one I used. Would I recommend it? I can't recommend it wholeheartedly because it wasn't particularly easy to use. The only other scope I've ever had are these Keysight scopes. I got the Pimp scope and this other one they sent, and I can't really voice an opinion on them because they were sponsored, right? Like, you know, my opinion of them has been bought, so like I can't remove that influence. So yeah, I think that's it. What the hell is Chibi OS? I've never even heard of this. What's Chibi OS? It's a free embedded RTOS. Oh God, am I gonna have to develop on RTOS? Son of a gun. Well, the STM32 parts are there's a huge range of them, and the Kineta series. These are teensies. The NXP Kineta series are teensies. All these are strong parts. The MK20 DX256 is, I don't think it's ever been used on TNC. It might be 3.2. It's the next one up from the one on 3.1. I know that for sure. This only has 2 I2C buses, I believe. So I don't think this is going to help us any. But let's take a look at the other ones here. STM32. I don't know very much about the STMs. I haven't used them outside hackathons, and if you take a hackathon seriously, you're not going to remember a lot of stuff that happens during the hackathon. So let's see, I2C. Where's our product selector? Let's see what we got. Spy UART. Where's I2C? Here we go. it doesn't let me pick the number of I squared. Oh, all right, here we go. So we've got these so we can sort these by I squared C. Looks like a lot of these have 4. It's still not enough. We need 6, remember. But actually, I'm wrong. We only need 3. These OLEDs, the SSD1306s, have 2 addresses that you can pick between. So each bus can easily have 2 of them. I already checked none of the addresses don't collide with. I'm sorry, it doesn't matter. The I/O expander has 8 possible addresses. So there's no way we have to worry about about collisions. So as long as we pick one that has 3 or more I squared C's, we will be in business. Looks like all these STM parts have 4 I squared C buses. So that's fine. Hang on. I was wrong about the Teensy. The Teensy has 3 that can be mapped across 8 combinations of pairs. Do we want to use that? Do we want to use the Kinetis? I don't think that part's available. Actually, no, I'm wrong. I was going to say I don't think that part's available leaded, but I don't need to think about this because I have one. Let's grab it. Where I keep forgetting I don't have to yell when I step away from the computer because now I have a headset. I also bought a compatible what do you call it? Compatible lapel mic. And at some point we're going to try that. All right, here we go. This is the pre-programmed. Let's actually go over here. So this is the pre-programmed bootloader microcontroller from Paul Jofferson. This is how he makes money on this thing, and that's why you don't see any rip-off TNC boards, because he was smart and he didn't release his bootloader for other people to reverse engineer. This is the MK20DX256, and sure enough, these are leaded components. I've never worked with these on their own. Yeah, I've never worked with these on their own. I've only done them with. I've only used the Teensy with his bootloader, so I don't know how hard this will be. Let's see. Selecting an MCU early initialization. QMK uses ChibiOS as the underlying layer to support ARM-based devices. Each ChibiOS-supported keyboard has low-level definitions, which are responsible for initializing hardware such as clocks and GPIOs. Can we run Arduino stuff on this? I guess like if we could just import Arduino, right? I'm getting a little worried though. I'd rather stick with the. I don't know. I'm getting a little cheesed here. I'd prefer to stick to the Arduino because I don't have a lot of time to learn new stuff. Let's see. The function early in hardware pre's the earliest possible code that can be executed by keyboard firmware. This is a replacement for ChibiOS's. Am I getting it? What do you folks think? Am I getting into too much of a rabbit hole here if we try to develop this for the MK20DX? Or should we just stick to what we know and use the Arduino and then add in, I guess, three I2C expanders? All right, let's table this for now. We're going to go back to DigiKey and let's look for an I2C expander. Because if we can get a 1 of 3 expander, then I think it's the simplest choice is just use what we already know. I know it's not sexy. For a lot of people, the learning and the experimenting with new things is part of part of the hobby of making. I've never once experienced this in my entire life. I despise learning anything, especially when I'm under pressure. And since getting serious about this channel, I have been under constant pressure. So let's see. What do we got? Interface, I2C. And it's fine to grab the other ones because, yeah. It's fine to grab the other ones because we just won't use them. Number of I/O. What does this mean? These are I/O expanders. No, that's not what we want. We want, let's see, multiplex. A multiplexer. There we go. Current. So folks are asking what the day's Mio is. Reagan says Zack is powered by Mio Energy Black Cherry. No, today is Strawberry Pineapple Smash. I forgot to switch back to here. Today is Strawberry Pineapple Smash, given to me by Trucku, and he sent over some of this super fancy Stratasys brand support filament that I still haven't had a chance to use yet. Ideal sound and performance says, why use an I2C expander? I've run 5 I2C devices in the same bus with 0 issues. Because SST1306 displays only have 2 addresses. You only pick between 2 addresses. So yes, you can put 120. In theory, you can get 128 devices on the same bus. In practice, you can't really go more than about 20. Doesn't matter because we only got 2 addresses, so we're gonna have a collision. We need to be able to multiplex them. Analog switches. Is this gonna help us? I2C mux. Let's see what we got here. We want a 3-to-1. Is that gonna help? I2C triple 4-to-1 multiplexer. Unfortunately, it is a leaded component. Is this even what we're looking for? Because I don't like the word analog. That's creeping me out. Is this what we're looking for? I2C compatible wide bandwidth triple 3-to-1 multiplexer. So it gives us 3 lines. Monolithic CMOS devices comprising 3 3-to-1 multiplex demultiplexers controllable via standard I2C serial. The CMOS process, blah, 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 blah. They conduct equally well. 2 general-purpose logic pins controllable with your I2C, which can be used to control other devices, blah, blah, blah. So can this be used to switch I2C? I2C is different. The reason why this matters, like... So you might be. So the question is. So another question you could ask if you're really on the ball is, why not just bit bang the displays with the multiplex? Why not just bit bang the displays? And I'm a little worried about. I don't know. Hang on a second. Now that I'm thinking about this, maybe it does make sense to just bit bang the displays. We're gonna have lots of free GPIOs. Maybe we. Yeah, I think we just use the Atmega 328U and just bit bang the living crap out of these things. Bit banging means, like, instead of using a dedicated I2C interface, we just switch GPIO pins high and low as if it were an I2C interface. It's not as high performance, but then again, we're not playing animations on this thing. Like, all we're doing is displaying little icons so that we know what each button does. Yeah, let's just bit bang it. Screw all of this. Let's just use the Atmega 328U and bit bang the living crap out of it. No reason to make this harder than it needs to be. Yeah, no reason to make this harder. Remember, never do yourself what someone else has already done. Never use someone else's solution if no solution will work. A problem avoided is better than solved. Yes. It's better to avoid a problem altogether than it is to solve it. 'Cause solving a problem adds one more thing that can fail. Yes, this has been your Voidstar Lab life lesson. Okay. Let's think here. We could just get the Arduino schematic and just like copy and paste it in here. You just like straight up copy and paste an entire Arduino Leonardo. Pardon, or Arduino Nano? Micro? Which is which? I don't even know it's real anymore. I think we want the we want the Nano. Micro, not the Pro Micro. I need to look this up. I've been using too many teensies. Arduino Micro. Is this the one with the built-in USB, or is this the one that you have to bring your own? Yes, based on the Atmega 328U for. Yep, that's our boy. So we could just Control-C, Control-V this schematic. Why not? Again, engineering is best off avoided. Okay, fine. If you want to learn something, then knock yourself out. I don't know, but like in that case, I don't know. I don't know why you people do things like that. I don't know why you people are interested in knowledge, trying new things, exploring. People are weird. Okay, here we go. Let's drag this guy over here. Unzip. Boop. Micro reference. So this is, let's see. Is it going to try to open it in the same window? Nope. We got a second instance. Heck yes, I want to open up the Heck yeah, I want to open up the schematic. Where is it? Where did it go? Why isn't it open? Is it going to open a third instance of Eagle? Warning. Do you also want to open blah 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 blah? Yes, I do. What's going on here? Why is nothing being displayed? What's going on here? What's happening here? Why isn't it opening? Why does Eagle got to do like this? Roses are worked fine when I did it close the other one? No, it's good. On OS 10 on Mac, you can't have 2 instances of Eagle open. I busted my ass trying to figure out how to do it. Just can't. You can only have 1 instance of Eagle open. All right, look at that. This is Arduino schematics are great. Look at that. That's a great board. It's a 4-layer. It's a 4-layer boy. So they put theirs in a frame because they're cool like that. Oh, look at that. Look at that little detail. That's cute. That's nice. I like it. All right. So we don't have to worry about voltage selection. We don't. Do we need a regulator? No. This isn't a 5-volt device. What's the 3 volts for? Okay, I've never really looked deeply into the schematic of this thing. What's this for? Show at. What's the point? Why is it? Oh, because this regulator is just for the user. It's not even used internally. That's weird. I guess they wanted to make it compatible with Shields. All right, so this is our USB micro. We don't want that. We don't need it. But let's group all of these bad boys. We'll edit it afterwards. Copy. And I think this works. I'm like 65% sure. There we go. Yeah, paste it. Conflicting net class. We got some nets of the same name. That's fine. That shouldn't cause any problems. But just to be sure, go over here. We should have. Yep, it pulled in all the. It didn't. Unfortunately, it didn't pull in the layout, but that's fine. We would have changed it anyways. We're also going to swap this guy out for the leaded version. Let's rat's nest this up. So yeah, you notice that there's only 1 air wire connecting this entire cluster to here, and that's ground because they both have a ground signal. This is good. It shows that when you paste something in, sometimes 2 nets have the same name, and it connects them internally, and that raises all kinds of hell. All right, what else are we going to need? We're going to add in our USB port as well. We don't need. All right, these things at the bottom here. It says not used because they use a resistor network. We can replace these. Boop. We can replace those with 0603s or something else. Pasty paste. No, we can't paste them in there. We have to paste them in the board in the schematic editor. Boop. Conflicting net class 0. Buffer. Blah blah blah. Overwrite net class, drawing net class from buffer. No. I've never used that feature. Let's see. Do we need to cargo cult in anything else? We don't need the footprint. The ICSP header. Ooh, that's a good one. I wouldn't have thought of that. ICSP header. Yeah, we're gonna need it because otherwise we'd have to pre-program the microcontrollers. We have to pre-program the micros with the bootloader, which I don't have the equipment to do. So, yeah. Now we've sprayed components all over the place. Very nice. Oh, very cool. I have covered chat, so I've missed anything that happened within the last few seconds. Doesn't look like anything that much. Omega Rogue says Pro Micro is a SparkFun part. I forgot about that. You are correct. Maxime Santerre says, what's the best way to learn about passive component use in circuits? I'll give you the same answer I give for every time I get asked to learn anything. I mean, the best thing to do is to take a class, but if you find that mind-numbingly boring like I do, just dive into a project, and when you need to learn it, look it up. Yeah. So let's see. We're gonna switch over here. All right, we're gonna. All right, so let's do this. We're gonna replace. It's gonna take a bit. Let's see. We want the @mega 32u. What's TQFP? What's going? What? Oh, I'm sorry about that. Is the same part available in a 32-pin package and a 44-pin package? Why the hell did they do that? Oh, it's a 32U2. I think this should work. Pin HWP2 in the old version can't be mapped. What are they? What library are they using? Let's library Gen Comp. Is this one of their? Is this like an? Did they design this part specifically for this? Yeah. All right. Well, hang on a sec. Let's add the part. I want to see how these compare. They might be similar. These look pretty darn similar. PE6. These look pretty darn similar. I guess we could add it, right? Like we could open up the package and are we creating too much work for ourselves though? Is this worth it? Just the library pass or export the libraries? Yeah, we could export libraries. Let's think here. Is this worth it? Right? Is it worth exporting the libraries? And I think so. The first thing I just want to check first. I want to look at the datasheet and confirm that the two parts have the same pinout. That like they're literally the same part. They're just in different packages. So let's look into that. Alexander Kraus asks, what web browser are you using? It looks clean. I'm using Edge because I trust Microsoft more than I trust Google. Right, so we want to do the @mega 32U4 data sheet. Do I even have it? @mega 32 PDF. Nope. 32U4. There we go. Here we go. All right, pin assignments, pin out. You never write. It's like plugging in a USB port, right? Like you search for pin out, it's always pin assignments. You search pin assignments, it's always pin out. Pierce says, "Is it worth it?" Someone didn't read the thumbnail. We're doing it the hard way, but but like it's up to us to determine how hard that is. So looks like the two pinouts are the same. So it says QFN, that's the no lead package. That's just the square, and QFP flat pack, which means that the leads are splayed out like it was that spider I smashed last night. I don't know where the hell these spiders are coming from. There's so many spiders in this apartment. I don't know where the heck the spiders are coming from. @mega 32U4 44-pin QFN or QFP. Ideal Sound and Performance says, I'm sure a library with 32U4 wouldn't be hard to find, and yes, I think 32U4 has multiple pinouts. Well, what I'm looking for here, so the plan here is not to use a library, because I don't want to have to reconnect all those traces by hand. Instead, we're going to dig into a library and find a footprint, find a QFP44 footprint. And we're then going to export the libraries from the Arduino version, right? Edit that device and just add in a new version. It's super easy. Ideal Sound and Performance says Edge is written by Google. I mean, Chromium is written by Google. Edge implements Chromium, but it doesn't have Google's analytics in it. Brian W. says, bruh, spiders kill mosquitoes and beetles. That's right, but all the spiders here in Colorado are poisonous, and we have a dog. So I want to protect the dog. Unfortunately, the spider bros have to go. The pinouts look the same though, so we're in biz nasty. So let's get in here. And how do you export? How do you export the libraries? There's like a button for it or something. I think it's really easy. Where is it? File, export. Yeah, there we go. Export libraries. So export original libraries or merge into one library. Original library prefixes as unchanged symbol. Do we want to merge this into one library or not? Yeah, let's merge this into one library. And we're just going to throw this library in our libraries folder. Library, Eagle, external libraries. And there we go. I like how like half the functions in Eagle are just running a script. It completely disregarded where I wanted to save the library, and it stored it in that folder anyways. Great. That's just the Eagleist. Let's see. Dropbox, library, Eagle. Let's see what ended up there. External libraries. Let's see what ended up there. I have so many friggin' libraries. Date modified. Cyberdeck, Mech. Did it save it in both places? I'm confused. Why is this saying... Oh, never... Oh, it's named after the prod... Did I export the wrong one? Oh, no, yeah, I exported the wrong one. I should have exported the Arduino one. Oh, whatever. Now we have... This isn't the end of the world, because now we can, like... hand out the library with the we can hand out the library with the project. It's a pretty good idea. Loco asks, when will the live stream end? That's a good question. Probably around 5. So we have a bit left. Ideal Sound and Performance says I PM'd you a schematic for 32U4 with USB-C already. You'll need to forgive me for let's see. Does it use the leadless component? Let's take a look at it. Normally I wouldn't. Let's see. Let's see. Normally I wouldn't look too close. Like, well, first off, that's an easy EDA, so it's not Eagle. It's not the schematic I'm worried about. It's the work. Like, I could easily re-implement the schematic. It's just the number of minutes it will take to do that. But yes, now that we've exported this, we can. Well, first, we need a pack. First, we need a donor. So let's open the Adafruit library, because we know for a fact that it has this part in it, right? So we're going to open Adafruit's library. We're going to find the package. It's going to be called TQFP44, hopefully. No, it's not. I'm confused. Let's just open up at Mega 32U4 and see which one they're using. This is called TQFP44. What in heck is going on? Package TQFP44. No, not new. Where is it? TQFP44. Why did I miss it? There we go. Group all. Copy. Whoop. Okay, now we're going to go in here. We're going to open up our library here. Open. Doesn't matter. Was not. Please adjust the library path. I did export the drawings, you stupid thing. Let's replace this part. Make it 32U. Why isn't our library showing up? Why isn't our library showing up? I am a little on the confused side. Let's see. Library, Eagle, external libraries, and we're going to use, I think it was called Cyberdeck. Yeah, Cyberdeck Mech. Now we're using it. And we should have our version, and we don't. Where is it? Where's our? Why isn't it showing up in our new library? What the hell is going on here? And why doesn't this ever remember why doesn't this ever remember our library folder? You might wonder why I'm going through all the trouble of putting my libraries on Dropbox. Because Because like my computer gets destroyed or I have to access this stuff remotely. Like I have to be able to get work done. Here a list of valid it didn't export any of the devices. It just exported the packages. That is profoundly stupid. What the heck is going on here? That's so dumb. Oh my gosh. Should we just use Adafruits? I think it would be quicker. At this point, I think it would be quicker to use Adafruits. Let's just use theirs. The point I want everyone to come away with here is that nothing gives you a right to be a lazy engineer. It's really tempting to say, you know what, it'll take a lot of work to replace this with a leaded component. Like, I'll just use this one. Well, you know, tell that to people who now are interested in building your project and say, oh crap, I don't have the ability to reflow solder. Yeah, like I don't have the ability to reflow solder. Like I can't build this project. And then you explain, oh, I did it to save time. And they're like, thanks, asshole. Like, you've completely cut me off from building this project I wanted to make because you wanted to save an hour. Like that's friggin' selfless of you. So this is a... So these footprints are significantly different. Or these schematic symbols are different. Maybe I can download them. Now that... Hang on a second. Let's back up here a little. Arduino Eagle library. Maybe I can just, like, download their library, right? No, I want the official Eagle library that they use for their products. Official Arduino Eagle library. Custom Arduino connector. Do they just where not the Adafruit one. Where's the? I guess they don't have it. Does anything change if I run it from here? Let's dump them into the Cyberdeck library. Let's dump them in the Cyberdeck folder and see what happens. I tried to merge them into one library. Maybe that caused things to get crazy. Maxime Santerre says, I imagine he has a reflow oven and stuff. I'm not that fancy. I have a hot air gun and a hot plate. At least it's like at least it's like a board preheating hot plate, not like a hot plate. Maxime says, what's the benefit of an oven versus a plate? The oven does all the soldering for you. The plate just preheats the board to make it easier for you to pick up the slack with a hot air gun. So you can technically fully solder a board with a plate. I wouldn't recommend it though. The heat's not even enough, and you could easily end up scorching or overcooking one part while leaving another part raw. Effing raw. This board is raw. Yeah. Let's see. Okay, so this here. So this looks like it got what we wanted. Wait, what? We only get one device? Oh, it exported them by library. All right, so let's go into our projects. We're gonna Dropbox projects, active projects, Cyberdeck, and I'm gonna go in the Mech section because this is only part of the project here. And what's the library we want? Microphillips, pin header, resistor, supply varistor. Oh, sorry about that. GenComp. I think this is the one. I think this is Dewey. Sauce Pasta says, I've seen people soldering with a plate using low melt solder paste. Haven't tried it. So actually the Singularitron, the original Singularitron, actually both of them were made with low temperature solder paste because it just wasn't practical to solder all those parts together. So here we go. Very nice. Wait, it includes it? Why would they even... I'm so confused. I didn't even know Eagle did this. That's what happens when you hate learning. So we'll run, I think this works. Run the tech command and swap it out. Yeah, there we go. It includes it right there, and the whole friggin' time. Oh my god. Didn't have to do any of this work. Time was all wasted. I had no idea that it pulls in unused footprints. Oi, Vault! Anyways, the low melt solder paste is pretty slick. It melts at a very, very low temperature. It's pretty cool. It's good for rapidly prototyping very intricate boards, especially multi-layer ones. Problem: if you rework it with any regular paste, basically, like, you know, if you have to pull off a component, replace it, right? Like, if you ever mix low temperature solder and regular solder, it forms an amalgam that's extremely brittle. So using low temperature solder paste permanently locks you out of ever reworking your board, which for me is a problem. Yeah, I ended up doing it anyways. So the original Singularitron board was very fragile. Effing roar! Alright, well, this whole thing could have been avoided. We wasted tons of time. Live and learn, right? See why I say I hate learning? Because it's never done voluntarily. So let's take a look at this. So we cargo culted in a schematic. Let's confirm that everything here is stuff we actually want. All right. So first, right out the bat, we have a reset button. We have a reset button. We don't need a reset button. We do want the ability to reset it. We don't need a reset button. So instead, we are going to add R0603. We're going to add an American resistor. Because I like squiggles. You notice that they're using. Let's see if we can find a resistor on here. Yep, they're using the European symbol. We're using the American symbol because we like squiggles. All right, check this out. If you want to save some space on a board, but you still need to reset it, just add in a 1 megohm resistor, or really anything. It doesn't matter, as long as it's much higher value than any possible pull-up. Throw that resistor in there, and there you go. This is now a reset button. How is a resistor a reset button? What the heck, Zack? It's really easy. When you want to reset it, you just grab a pair of tweezers or a screwdriver or something, even a pair of keys, and short it. There you go. You've now reset your board. Super easy. Let's see. Daryl asks, Zack, is it possible for rubber dome keyboards to use 3D printing to make a new stem to be MX compatible? I mean, that depends on the keyboard. Like as I said before, if the question is it possible? The answer is generally yes. The real question is it practical? I would say probably not. The keys usually float freely in. Like, they're usually they have a custom stems that float freely in a case. So yeah, I guess you could make stems. You'd have to add some sort of. You probably have to make them in two parts that snap together to retain them. Again, I don't know why you do that. Like, at the end of the day, you'd have a Dell keyboard that has fancy keys on it. So I guess you get internet clout, but you'd still. It's a lot of work and energy for a mushy feeling keyboard. I mean, you could just get some. Like, if you want to do that, just buy a Logitech keyboard and get some topers. Oh, burn! JS Diddle says, Zack, on average, how long do you spend on a project per day? Depends on your definition of project, but is generally in the neighborhood of 12 to 14 hours. If you count videos as projects, like if you count content production as projects, then I'm spending 12 to 14 hours, give or take, per day. Otherwise, it's either 12 to 14 hours or it's nothing, because I'm working on videos. Yeah, the amount of work it takes to run a YouTube channel, the amount of work it takes to run a YouTube channel with videos that require me to do stuff other than look at a camera and talk is unbelievably high. There's a reason why I'm doing these streams, and that is because it's just not practical to make enough things for you folks to see. Yeah. No, it's just not possible to make enough for you folks to see. Like, there's just not enough hours for me to make videos about everything I want to make. We got stuff like laying out boards, resin printing, 3D printing stuff that it's not. If I put them in an episode, it would be like 5 seconds. And this is the opportunity to go deeper into them. I have to be very selective because I can release so few episodes. I have to make sure everyone is a banger. It's part of why I gotta chill the heck out when it comes to this channel, or when it comes to the streams. Because, I mean, this is supposed to be like a time for me to unwind too. By the way, we're in the process, we're in the process of migrating this to Twitch. Eventually, live streams will all go to Twitch. And when I say eventually, probably within 6 weeks or so, maybe a bit more. We're gonna move them over to Twitch because the demands that the YouTube streaming audience have just make streaming so hard. Like people expect streams on YouTube to be the same quality as videos on YouTube, which is ludicrous. It's not possible, at least for me. But yeah, we'll end up putting this on Twitch. Twitch also gives us a bunch of, on top of this, Twitch's API effing rules. Twitch low-key has one of the best APIs I've ever seen. This is well known. We can within a few hours, we can like tie the Chromance, the shelves, all the stuff into Twitch. It's super easy to make bots that communicate with stuff. It's great. Brody Young says, has anyone tried micro soldering? I had a repair that needed it. I couldn't do it. I do. Carl Fetterman says, can you not do both YouTube and Twitch? It's kind of the worst of both worlds. YouTube audiences just, for the most, of course, you folks are the exception. I'm going to keep designing here. We don't need this in Doctor. We're not using any analog inputs. We don't need a steady analog ground. Or we don't need a steady analog VCC. So we can replace that with a dead short. Yeah, you folks are the exceptions, but for the most part, YouTube audiences just aren't so jazzed about the streams. Whenever I announce anything stream related, the response is generally like, meh. And whenever I post, yeah, I can't do stream tomorrow, the answer is usually, I didn't like streams anyways. I actually lose subscribers on stream days. On a normal day, depending on how well the recent videos have been doing, I get between 100 and 300 subscribers. But on days when I host a stream, I actually lose about 10. So, yeah. Arrow Raider says, the world would be better if Twitch never existed. It's a scourge on humanity. I disagree. I think you could argue the world would be better if booby streamers didn't exist. I think the world might be better if toxic trolling streamers don't exist. But as a whole, absolutely not. It's a marvel of human ingenuity, and it's a great way to get people involved in the process of things. Instead, videos give people a heavily processed, sanitized, narrativized version of how things happen. And Twitch and other live streaming platforms give people a look into how things actually are done. And they also are better for allowing relationships to form. It's hard to form relationships with a character, right? To some extent, I'm playing a character when I am, when I'm in my episodes. And it's different, it's not, it's different when you can have a conversation. Yeah. Okay, what else we got here? We've got some LEDs. Got what's this? Is this just like a built-in LED? What's this guy? What's PC7? What's this? What does a green LED on an Arduino Nano do? I have no friggin' clue. Let me grab one. I think I have an Arduino. I think I have or is this a micro or a nano? What do we end up picking here? I forget. What are we even doing with our lives? Let's see. We got Nano BLE. We've got a lot of micros. I bought a few too many of them. We got Pro Micros. Not the real deal. I don't actually have an official Arduino Nano. I only have Arduino Pro Nanos. Or Pro Micros. Nano BLE. Yeah, I don't even have one to look at. I don't even remember what project to put it in. Yeah. Arrow Raider says, who are these people who think YouTube streams have to be the same as videos? The people who make Our streams have a 0.3% click-through rate and a viewership about 1/20th of the streams. Yeah. It's just, I mean, you see the analytics. Like recorded streams get recorded streams get, you know, maybe 10,000 views, and even a mid-level video on my channel gets around 100. Yeah. Marty says, I'd estimate you get 2,500 viewers on Twitch within 2 months compared to 200 on YouTube. It's hard to say, because Twitch is a very rich get richer platform. Main way people on YouTube, right? The main way people find videos, the main way people discover new people, they discover new stuff, is by recommendations. YouTube's got recommendations everywhere. The primary way people find out about stuff on Twitch is through a top list. Basically, most people discover a channel on Twitch by going to a category page, and those are generally sorted in descending order of viewers. So effectively, I am responsible for bringing in my own, basically like each stream, without any help from Twitch, without anything, no notifications, no nothing. I exclusively Zack Freedman with no help have to bring in the first. Actually, let's find out. Twitch. I'm kind of curious here. Twitch.com. So we're gonna go to Twitch. Here's how people will find me. All right, look at all these. All right, so here's how people are gonna find this. They're gonna click IRL. They're gonna click Science and Technology, and I think this is. Let's make this window half the size, right? To more close. So all right, there are 9 in view. Number 9 has, all right, so currently this is a slow time. This is 22 viewers. So I'm responsible for bringing my first, in this case, 23 viewers, so that I show up here and then people can click through. So, yeah. So you'll notice that this isn't strictly speaking sorted in descending order of viewers. There is some jitter, but on the whole, like you see, most of these have hundreds of viewers. So I need to meet that without Twitch's help to appear at that place in the list. Then I start getting more viewers as people discover the channel. So I'm not sure that I'm actually capable of so right now, the only platform I really have, so I have like, I don't know, 8,000 followers. There are 8,000 people on the Discord, of which about 2,000 have notifications enabled. We've got around 6,000 Twitter followers, 6,000 Instagram followers, and YouTube. I don't think YouTube is gonna promote a Twitch URL very effectively. So basically, we don't have the platform yet to do that, and we're gonna see. I'd really like to do it. I'm just not convinced it's gonna go anywhere except a giant wet fart. Anyways, let's look at Arduino Nano. Or is it the Arduino Micro? Yeah, we're looking at the Micro, not the Nano. I only have Pro Micros. That was the problem. Because these are really, $20 for this is very steep. Like $20 for a teensy, I think that's reasonable because of how powerful it is and how well supported it is. But yeah, so what are these? We've got 4 LEDs to worry about. We got the TX and RX LEDs. We can just kill those right away. RX LED, is this it? Yep, RX LED. Get rid of that. We don't need it. I don't need it. And TX LED, we don't need that either. There's no serial traffic we care about. What are the others? We have a green LED and a blue LED. One of them is probably just connected to pin 13, right? IO 13, is that it? Yep. So we don't care about this one. This is the pin 13 LED. What about the blue one? The blue one is just a power LED. You don't want a blue LED going on your keyboard at all times. At least I hope not. So that's it. Yeah, we don't need any of these LEDs. Let's get rid of them. Gotta be super careful to not make assumptions. When it comes to electronics, every assumption gets punished. You can't be even the slightest bit lazy, because I find that I get punished for laziness about 100% of the time. Hot tub hacking, yes. Twitch is also just a better streaming platform. And like it also, like, YouTube streaming is just, there's a lot of paperwork you have to do. YouTube, in order to set up a YouTube stream, it's the same as a YouTube video. Everyone needs its own thumbnail. YouTube won't show multiple videos with the same thumb. YouTube, I'm not very subtle. Not sure if you ever noticed this. YouTube never recommends 2 videos with the same thumbnail. So they all have to have different thumbnails. They need to be tagged for discoverability. They need to have a description written out. You need to say whether there's paid placement or anything like that. You have to set audience limitations. You know, if you want the thing to be to increase discoverability, you want to add a location, recording date, which is weird because obviously it's being recorded now. Like, when the hell else would the stream have been done? And all that other stuff. You also have to designate there's no way to set a recurring stream. Everyone has to be created independently. It's a giant pain in the butt. Yeah, there's a lot of paperwork and busy work that has to be done. Afterwards, every one of them becomes a VOD in full. There's no way to create highlights easily on YouTube, so I have to go back and cut out any crap, right? Like, you know, just go back through and cut out silence or anything I don't like. It's a tremendous amount of busy work. Yeah, so it'll be nice to get that time back. It's also very hard to run the streams themselves. Mods don't have the same privileges here than they do on Twitter, than they do on Twitch. Man, I'm never gonna get properly caught up on my sleep, will I? So what do we got here? We've got our USB. We got some Zener diode. Oh, this is all right. So let's go back here. Let's check out the other side. So what else do we have here? Our reset line, we have a diode, probably because we have a reset pin, right? Let's what's up with the diode? What is this? Mini Melf. What the heck is this? Is this a Shocky diode? Like, why is there a diode on the reset line? What's the point of this thing? I don't want to just delete it because I know that'll be a problem. But what's the point? What's the point, Walter? Is it isolating the button? No, it's going to 5 volts. What the heck? Is it like to isolate the GPIO? Sorry about that. What's the point of this? Volt. Let me think here. Let me think real quick. Think. Oh, let's see. I'm not currently on Twitch. I don't believe in multicasting. I think it's multicasting is disrespectful and tasteless, in this guy's opinion. I think it's, on top of that, there are quirks to each platform, and you need to honor those. You have to respect your viewers. Reverse polarity protection? I don't think... I'm profoundly confused here. What is the point of this thing? The reset line? I added this resistor myself. A diode on the reset line. Is reverse polarity possible? Like if we invert the polarity, why is the reset line different? I'm really confused. Overvoltage protection? To the reset line? Is it particularly sensitive or something? TKM, thanks a lot for the super chat. I'm about to drop some money on Teensy 4s and some Arduino junk to jump into electronics. I will get the Singularitron modded and working. Go for it. Yeah, I hope you know it doesn't really have a Teensy in it. Like, I implemented it myself. Voltage protection? I'm really confused. Chat gets fragmented. That's a part of it. It requires people to make a decision about which platform they go on. Again, we don't want people to make decisions. I'm going to kill this diode. I've never put this into my own Arduinos. That diode's dead to me. Let's move this a little closer. On top of that, there are different things like super chats on. You got super chats on YouTube. You've got subscriptions. Subscriptions are different. That confuses the hell out of people. Like if you say, "Hey, thanks a lot to X for subscribing," then people on YouTube are gonna be like, "What the heck? I just subscribed. He's not saying crap. This guy sucks." when in reality, like, they don't know that on on Twitch, subscribing is super. It's like a donation. It's almost sort of like a super chat. It's like a YouTube membership. What else do we got here? What have we cargo culted in? What's VCAP? What the heck is this? What's VCAP? What does this do? Or is it UCAP? What is the point of this? What's the U for? Oh, is this USB? All right, so this must be part of the USB. All right, the analog reference is getting decoupled to ground. We are not using the analog pins, so we don't need that. We could also, I mean, we could leave the footprint and just not populate it, but I don't think that's necessary. So we got our analog reference. We don't care about this. Get that crap out of here. Yes. Maxime, thank you so much for the very generous super chat. I totally appreciate it. Thanks for answering all my cues. Looking forward to hot tub streams on Twitch. Oh my. You're going to see a lot of them. I mean, Twitch is about to get, like, OnlyFans just got kind of shut down, right? Like, the part that people used OnlyFans for kind of got kicked in the teeth. So I think you're going to see a lot of simp baiting. So get ready for that. It's going to be fun times. Yes, hot tub streams. Sebastian asks, wouldn't it be a Zener to provide voltage regulation? I suspected that, but it wasn't the symbol for a Zener. It was a symbol for a regular diode. The Zener has the little on it. It's pretty cool. Yeah. Yeah, I don't think it's necessary. I was thinking of doing OnlyFans, but now the joke's not going to work anymore. I don't think it's going to be as funny. OnlyFans is going to go the way of Tumblr. Calling it here. Calling it here. They tumbled themselves. Congratulations. You tumbled yourself. Let's move this in. Yeah. They have somehow kidded themselves into thinking that people went there for a reason other than juicy prawns in cocktail sauce. All right. Let's add our resistors again. Let's do a boop boop. Let's get our value of 22. One thing I don't like about Windows, see, I'm not a total fanboy. One thing I don't like about Windows is that it's a lot harder than Mac to type symbols. So before I could actually like type, type ohm, but now I can't. Maxime, thanks a lot for the super chat. It's very generous. I totally appreciate it. You're a legend, I say. How did we end up off grid? How did we end up with all this stuff off? How did we end up misaligned with the grid here? Oh, that OnlyFans. Is it a good thing? I mean, that requires you to, let's see. How do we get this to snap to the grid? That requires you to consider. Requires you to consider that type of stuff morally wrong, and I don't. What the heck is going on here? Why is this? How'd this end up off grid? I didn't do that. 0.1, 0.05. Yes, it is strongly recommended to use the default spacing in schematics. I completely agree. Let's see. Yeah, it requires you to think that stuff's morally wrong. I don't. Is it kind of trashy? I guess it's kind of trashy. But you want to make simp bucks. Make your paper. Caveat emptor. So let's see what we got here. We got VUSB. Do we want to keep this? Do we want that's interesting. So how does this go? What's going on here? We got the VUSB. Is this going to where's VUSB become VCC? Let's go back to the schematic and take a look at it, because we probably want those protection components too. Where's VUSB? Show VUSB. That kind of rhymes, sort of. So VUSB is going into a MOSFET, so that automatically selects between 5 volts in and VUSB. We don't need that. So we can just replace VUSB with VCC, or in this case, 5V5. So we have a 3-volt line. We're gonna need a regulator of some kind. Do we want to use their regulator? Well, let's not get too sidetracked. One thing at a time here. So let's get rid of this VUSB. Show VUSB. Right, we have a little bit of fuse action here. Do we want a fuse? I don't think the fuse is necessary. The fuse is important. I'm a little skeptical. So these are both connected to USB? What the heck? Why didn't they just connect? I'm really confused here. This is a very strange schematic. Why is this pulled down to ground? Why is there a burden resistor here? I'm very confused. This is a lot of odd details in this schematic. I mean, not odd in the sense of like the people at Arduino are smarter than I am. So I'm gonna give them benefit of the doubt here. Yeah, yeah. Look, I think the only bad thing you could say about like the booby streamers and the simp baiting is that it's making some people get like obsessed, but that's not the responsibility of the creator. That's not, if you get addicted to something, that's your fault, buddy. Yeah. Yeah. I think that's good. So we're going to copy in the 5 volts. Yep. I'm just so used to calling 5 volts VCC. I don't like this here. I don't like this ground going over the top. That is confusing as heck. I don't like that. Ground is supposed to be on the bottom. So let's get this. Let's get this guy here. Let's put this here. Boop. Oh no, come on. There we go. Move this around, add a net. Marty, thanks a lot for the super chat. Marty says, thanks for the secret aardvark hot sauce recommendation. Wife and I love it. Secret aardvark is so friggin' good. That hot sauce is delicious. If you've never had secret aardvark, get it. It's the best hot sauce in the world according to an app on hot sauces, which I downloaded because I'm a friggin' nerd. And it's delicious. If you like Bloody Marys, definitely get it. Don't just get it. Get it like immediately. Because it makes the most delicious Bloody Marys and micheladas of all time. So what do we got here? We got Zener diodes on the data lines. Zeners, or Zeners? No, that's not the symbol for a Zener. That's a symbol for a varistor. So you got varistors to ground. Is that really a thing to worry about? Are you really worried about overvoltage events on the data lines? Are we? Let's that's really weird. What's the point of that? I think what's the point of these things? I'm going to keep them. The reason why is because I envision this thing to be like hot plugged a lot, because it's going to be the split keyboard is going to be collapsible, and that can send voltage spikes through. And the data, like the differential data lines on USB are only like 1 volt, so they are actually very fragile. So I think for safety's sake, we'll keep that. Let's get this. Let's move this down a little bit. Boop boop boop. What was I saying before? Oh, right. I think this is something that Naomi Wu, sexy cyborg, gets drawn into every once in a while, and I don't think that's fair. I think her the stuff she makes and the way she does it, and the reasons she does it are different. So we got some test points here for D+ and D-. Am I gonna jig this up? We're not gonna jig this up. I'd like to make it. That would be kind of cool, though. It would be neat to make a test jig one day. I don't know what the context would be for that. So we got a USB micro here. We got a USB micro here. Don't worry. Don't worry. We're going to do something about that. ICSP, we got nothing to worry about here. We're going to need a voltage regulator. So we're going to need, we want 3 volts for the multiplexer. Or the I/O expander. Can the I/O expander? Let's look up the datasheet for this bad boy. I saved it so we don't have to find it again. PCA 9505, because we're also going to be using PDF. I friggin' saved this thing. Did I not? I guess I didn't save it. All right. All right. Let's hunt it down again then. PCA 9505 datasheet. Datasheet. Here we go. 2 to 5 volt operation. Oh, perfect. All right. Well, then there we go. We are going to need 3 volts for the OLEDs, but we don't have to worry about the I/O expander. That's nice. That's good. So for these guys, let's simple linear regulator. Let's see what Arduino used. Arduino. They're using an LP2985. Which one's that? Ultra low power 50 milliamp low dropout LDR. Oh, that's a very low current there. It's pretty low current. How much? SSD1306. I don't actually know how much current these things draw. I suppose we could test that, but I'm lazy, so let's consult the almighty Oracle. Oh, I never updated the to-do list. Connecting key switches, we're in the routing traces section. There we go. And if all things go according to plan, then we'll snuggle some puppies. We could do some prints here. Now I'm thinking about it. How do I bring up a Sauce Stella Pasta says, how do I bring up a search like this? That is Power Toys. It's free and it's actually written by Microsoft. So just head over and just search up Power Toys, and there you go. It's also where this window manager comes from, the one that makes everything snap. So what was I doing? SSD 1306, 128 by 32 module. Let's just find the first one and see if anyone says anything about current. MA. Current. How much current? Dear, it's about 10 milliamps. They call this. Oh. Hi. Are we better? Are we better? Are we good? Are we in business? Sorry, the battery ran out. Oi, Gewalt. It's not playing the opening screen. I'm seeing my face right there. It takes a second for the stream to catch up. Are we back?
Yep, now you're back.
You're freaking me out, lady. I love you too, Brooke. As I was saying before, I can't cut any corners. I get punished for literally every lazy decision I make. I go 1 week without replacing the batteries, and I run out. I have to do everything 100% because I get punished for every mistake. It's the nature of the game. Okay, so these take 10 milliamps. We can't use that one, so I think we'll just. I'll just add in the LD 1117. Yeah. Add in our LD 117, just your standard LDO. Is this available in any smaller packages? Let's see what I got. I'm sure I've used smaller ones before. Let's take a look at regular. Low drop out. So what else do we have here? We have ultra low power 50 milliamp device. 50 milliamp. Can we embiggen this? There we go. 500 milliamp. What do we got here? We got the LD1. All right, so that's a big hoss. We don't care about that. Linear devices. LP2950 available. Nope. This is better. This is going to be a bit smaller. Adjustable output LDO. We could use this. It's available. No, we don't want that one. Micro 8 or SO8. I don't think those are any smaller. Let's just use the LD117 because in SOT 223, I think people already have these things. 3.3. There we go. All right. We don't have a power area yet, so let's put this here. I've used these so many times. So let's do R1206, not R. We need a capacitor, 1206. There we go. And we need a capacitor 0603. There we go. This one here is going to be 10 microfarad. And this one here is going to be 0.1 microfarad, and there we go. This pin is labeled adjust, but that is incorrect. It is not an adjust pin. It is a ground pin. So let's get these over here. We'll net these together. Oh, compared to LDOs are so easy to make in a schematic compared to switching regulators. Switching regulators are diabolical. They have bazillion moving parts. They got inductors. They got like fucking weird ass value. You always end up having like a 50, not a 49, not a 51, not 51. You have a 50 ohm resistor that you need in there. It's part of the fun, I suppose. I'm going to have to standardize these footprints. There you go. Okay, now we got 3 volts. Very nice. What else do we need? Nothing here as of yet. We have to wire these up. We have SCL in it. These are all labeled serial clock and serial data, so they're all bussed together. But we're going to be bit banging them because we're cool. So let's wipe all these out. Why is there still a label? That's weird. Oh, must be. Yep, here we go. All right, so let's wipe out all these wires, because we're gonna be bit banging this. We're not hooking this up to an I2C bus. So these are gonna be called like SDA1 and SCL1. Yeah. And let's just add in some placeholders here, so that we have something to tie together with our Arduino. So I actually met Massimo Bonzi once at Maker Faire. We were setting up our booth, and he came over, and we were talking a little bit, and he pronounces Arduino Arduino, and it's delightful. It's delightful. He's got the thickest accent, and it's great. You know that Arduino is named after a bar? It was named after named after a pub called the Arduino. Or maybe it was like a club. Point is, there was a place they drank at. Alrighty, so let's connect this up. Let's wire this bad boy up. So first thing to do is we gotta figure out where the... Let's minimize this. We don't need any more. We've got to figure out where we're actually gonna put this thing. The way I like to lay out a board is you start with the rocks and then you add in the sand, right? You start with the big stuff and you go from there. So we've got this guy here. Oh, we have to add the USB. Oh my gosh, we have to add the USB. What am I thinking? Let's see. I forget the name of the part. We gotta add the USB though. So I use this part for the last client project that I really like. It is a USB Type-C connector, but it's all through hole, and I found it delightful to use. So it's going to be under Voidstar connectors, Amphenol USB-C. This is a hybrid version. This has SMD and through hole. This one's made by a company called Assman. There we go. That's our boy. That's our boy. And this is only, yeah, I've only broken out the USB 2 pins because those are the only ones we care about. So now it just comes down to connecting everything together. So let's... Why does this thing have 6 shroud pins? That's weird. It must be one hell of a USB connector. This will come in handy, so let's put that over here. So we got, that's pretty basic. So let's delete this, and it's pretty obvious where everything's supposed to go. Move this giant USB label out of the way. So yeah, we've got 2 pins instead of 1 for the digital, and we just connect them together. It's that easy. Why am I having so much trouble lining this up? There we go. So we got minus and plus. Actually, we probably want to do this like so. Yep. Plus minus. Oh, never mind. All right, I guess that's the way I labeled them. Whatever. This guy is going to go to VUSB. That connects it to all 4. You see how it says A4 times 4? That's because it connects to all 4 pins. All 4 VCC pins. That's why I was being so obnoxious when trying to get those pins internally connected, because I clearly got it working here. I don't know. I'll be damned if I could remember how. There we go. So these are going to be connected. A USB Type-C connector has separate pins for, you know, basically it has the same pins going left to right in the top, right to left on the bottom. So you can unplug, so you can plug it in either way and it works. But here, look at this. Look at this. These pins, like, you have the same set of pins top and bottom, but not necessarily. Yes, this thing will work the same way, you know, face up and face down. Because here, look at these wires here. You might not be able to see them, but these wires right here, these guys, they're connected on the board. They're not connected in the plug. They're not connected in the cable. They're connected in the board. There's nothing obliges you to make the USB port do the same thing up and down. You can connect 2 different USB devices so that one of them is active depending on which side is connected. Nothing forces you to actually implement it this way. You can make it do completely different things, whether you insert the plug face up or face down. There's your USB Type-C fact of the day. I've only seen one person abuse that, and it was vaguely terrifying. I'm going to be honest. We need to look up what we need for the VCC pins. These tell the host device how much current this thing needs, and I know that 55 ohms, 55k ohms, I think, is for give me an amp, but we don't want an amp. We only want 500 milliamps. So yeah, we gotta look that up. Let's see. Let's get our grounded to ground. All right, let's consult the almighty Oracle here. Let's see, USB Type See current resistors. Not. Power adapters. Provides reference information for manufacturers of USB parts. Interesting. USB power delivery. We're not doing that. Ugh. Resistor RP. So what do we want here? A USB-C to USB 2 Type A plug. So this is going to be USB-C plug to Type A receptacle, right? USB-C plug to Type A receptacle. I think that's right. This is for cables. I don't know. I don't know what this means. Maybe this is it. Over power delivery, yada yada yada. All right. Source port, sync port. This is going to be the sync. CC pins, port termination characteristics. Let's see. Source current capability. No, we want the other end of the the ice cream cone. Let's see. USB-C, 5 volts. Here we go. Default current based on spec. As stated in the USB Type-C, it's mandatory to determine the orientation, i.e., when one of the CC pins detects yada yada yada. It monitors both CC pins. The pins are floating when nothing's attached. Yeah. All right. So this is how it actually works. How it actually does the communication. So what resistors do we need? I hoped it would have a table in it. Sync termination requirements. Nominal value. CC pins. Send resistor to ground. I keep forgetting. This stuff is so confusing. I can see why no one ever implements this correctly. A source must assert RP pull-up resistors. A sync must assert pull-down resistors. So that's what we want. So we're a sync, so we got to put in the pull-down resistors. And I think we just want pin 1. Pins are floating, nothing is attached, but it's connected. One line is pulled down, signaling that a connection's been made. Which CC line detects a valid resistance? Source capabilities. I keep forgetting how this works. Oh my gosh. I just need to know what resistors we need. Default USB power. 56K. Resistor pull. So this is the sourcing. No, we want the syncing. USB Type-C cable needs a pull-down termination to signal it needs power. Must be able to differentiate between RD and RA and all that good stuff. Minimum impedance, maximum impedance. So when the power detection phase is complete, these devices have the ability to remove the RA resistor. Oh, that's interesting. So we just pull these down to ground. Yeah, just put in 1K resistor. Huh. This is why I look it up, because I always forget this crap. Add. No, you know what? We're just going to copy. Where's our squiggly boys? There we go. Change this guy's value to 1K. Copy. Group. Copy. Group. Wait a second. No, we don't need 4 of them. We only need 2 of them. Derpy. Herpy derp. Put these FUD puckers here. Give ourselves a little more room to play around with. There we go. There we are. And let's connect these guys. Yeah. Oh, USB, you so crazy. This doesn't change my opinion of USB Type-C. I think it's really clever. I think it should be implemented. I don't see any reason to implement micro USB, like, unless you need the thing to be compatible with cables people already have lying around. I don't see any reason why you should use micro USB. All right, that's it. So right now it's 4:30. Do we want to keep going? Because we're kind of coming to the end here. Let's wire up the OLEDs at least. Let's get those things connected. Power on reset. I guess we should also kind of try to wire up the. We should wire up the GPIO expander, shouldn't we? Let's do that real quick. Let's take a look at. Brooke says, "I missed. Did I miss a super chat? No, that was a while ago." Let's save this before something goes terribly wrong, and let's take another look at that data sheet. Wiring this thing up. These are my 3D these is my 3D printers. I don't care about that. PCA 9505. All right. Let's take a look at what we ought to do. So we want active low interrupt. These are input. So are these like active drain or anything? Do we need like pull-up resistors? To conserve power, no internal pull-up resistors are incorporated into A1, 2, and 0. So we need to pick our address here. Does it matter? Yeah. Open. The open drain active low interrupt is activated. So we need, so it's active low. So we need a pull-up. And the AdMega 32U4 does have internal pull-ups. So I don't think we need, so we don't need an external pull-up. Yeah. All right. All right, so we don't need funny stuff. So let's put this here, and we're gonna label it. Switcher around. There we go. I'm gonna name this. Putting a not, like putting a bang, an exclamation point in front of a name in Eagle will cause it to draw a line over the top, which is useful for keeping you from getting confused. So then we got this here. Actually, let's draw the rest of these things. We got our VSS pins. We probably want those bussed together and going to something something voltaic. Yeah, that's right. We should power our projects off of voltaic key, so we get to use them twice per day. That's a bit of a weird. That's a bit of an esoteric one. All right. SDA and SCL. I think we know where these ones are going. Pardon me. I guess we could connect. Serial date and serial clock. I guess we could connect two of the displays to it. Although I don't see any way here to choose the ID, so I'm gonna assume no. We'll just connect 6 of them. We'll connect one of them to the I2C. I don't think this guy here has a jumper or anything to pick the address. I need to look it up. I don't actually know what the schematic is for these things. We'll deal with that later. It's not important to do now. All right. So we have all of our address pins. This is a bit of a big brain pro play. We're going to connect all these to VCC. And that might sound a little weird because, like, why not just put them to ground? Like, why use one when a 0 would work? And that is because the ground plane absorbs a lot of heat. So the more pads we have connected to ground, the more pins we have connected to ground, the harder this thing is to solder. So this is a bit of a quality of life thing for the poor schmuck who has to actually assemble this thing, which, let's be honest, is going to be me. Yeah, there we go. All right, let's add a few labels. Oh, and here, and here. We're going to name this guy Sta. We're going to name this one Skull. We're going to name this one Not Reset. And we have an output enabled. Do we want to connect that? You know what? I'm going to break it out. Like, yeah, we're gonna break this out. But I don't think we're going to need it. I don't think we're going to end up using it. OE stands for Output Enable. Name. And basically that when this is asserted, when this is deasserted, when it's low or high or whatever counts as being off, it switches all of the outputs into high impedance mode. Basically, it's a safety measure during boot up to keep anything from taking damage, as like basically to keep yourself from momentarily creating a short as you switch things to output mode. But I don't think we're going to need it because, as far as I can tell, we don't have any outputs. Maybe we will, but at least for now, I don't think we'll need it. Output enable, it says it's active low. Let's take a look. The active low output pin enables you to enable or disable all IOs same time. When a logic low is applied, all the IOs configured as outputs are enabled, and the logic value programmed are applied. When a high level, all the IOs configured as outputs are 3 stated. So, for applications requiring LED blinking with brightness control, this pin can be used to control the brightness by applying a high-frequency PWM. Oh, that's kind of cool. LEDs can be blinked using the output port registers and dimmed using the PWM signal on the output enable pin, thus controlling the brightness by adjusting the duty cycle. That is really tricky. I'm not going to use that. Let's see. I'm going to leave myself a note. Pull this down if you don't use it, you jabroni. There we go. And that should be all of them. Let's see what decoupling we need. Schematic. So it's not specifying anything. So let's just, when in doubt, throw an 0.4 microfarad cap at it. It's kind of the rule, isn't it? So we got VSS pins all over the place, don't we? So these are all connected to plus 5 volts. Let's take a look at where they end up. Show plus 5 volts. So we got pins all over the place. Do we want to decouple all of them? Does it matter? Do we want to like just friggin' throw 6 capacitors in here? Are we that lazy that we're gonna pinch? Are we that lazy that we're gonna pinch 5/100ths of a cent? Let's decouple all of them. Why not? Why not? We're ballers like that. So how many do we need? We need 1, 2, 3, 4, 5, 6. So we got 1, 2. Let's group these. No, let's group these. I don't want to copy a wire. Copy them. Copy them again. And let's wire them up. Yeah, I'm not sure if I'm not sure this is necessary, but look, we could just not populate them. It's not, it's not a big deal. Remember, that part's the I/O expander, so most of it is wires. Like we're not going to need a lot of room around there to route wires, because like one side is occupied. It's occupado. So yeah, let's decouple that. All right, what else do we need? Reset pin. We want that to go to. Do you want to pull that up? No, it's gonna have a power on reset anyways. We don't have to worry about that. So let's see what we should connect where to minimize the length of our traces. All right, here we go. Let's get the @mega in view. Do a little rat's nest action. All right, well, serial data and serial clock, we already know. Or, yeah. So we're going to name this SDA. Yeah, heck yeah, I want to connect them. Heck yes. Very nice. All right. So this isn't a terrible layout here. We are definitely going to want to rotate this thing by 45 degrees. Because otherwise we're going to run into... Oh, there we go. Yeah, we definitely want to rotate this thing 45 degrees, because if we don't, we're going to have a really awkward time giving the crystal enough space. You really don't want to put anything else around the crystal, and yeah. we should also we made a mistake. We made a boo-boo. We're gonna group all these guys. Oh, hang on a sec. So, except for the USB port, all you Slime Rancher fans haven't found that one lately, have you? So, except for the USB port and for the ICSP header, all of our circuits are on the bottom. Yep, there we go. So here's something you can do really easily. So here's something you can do really easily in Altium that you can't do easily in Eagle, and that is flip the entire board over. Because right now we're going to be working with a lot of components that are mirrored. So we don't need this to serve its purpose. We don't need any more. We're working with a lot of parts that are mirrored. So things could get a little bit confusing, especially when it comes time to label everything. And it would be really slick if we just flip the entire thing over. We could do it. We just select everything. We mirror it. We make sure we remember what it's being which point it's being mirrored about, so that we can flip it back when we're done. I don't have that kind of patience right now. So let's take a look. Where's the stuff we're gonna need to connect? Which parts are we gonna have to connect a lot of stuff to? We got. Let's see. We got the crystal. Crystal's going to be over here. We've got the USB. USB is going to be over here. So I think we're starting at the wrong end of the ice cream cone. We should flip this thing around. So that's going to put the... See, that's going to put our crystal up here, away from all the action. It's going to put our USB port... Yep, our USB lines are here, where we can easily get at them. And we got lots of GPIO lines. Yep, IO, IO, IO. IO, IO, IO. It's still going to be a little bit on the awkward side, because we've got, let's see, what's D5? Is this a PWM? Digital 5? Yeah. All right. Why isn't IO9 attached to anything? Do they just not have enough room to break out all the traces? That's weird. That's really weird. Where's pin 29? Pin 29, IO9. That's not what they call it. All right, whatever. Point is, we got plenty of GPIOs. We're in good shape. So let's move this down a little bit. Of course, we're going to be able to move things around. These are going to have to be, so these traces here are going to have to be, I mean, we can route them on the bottom side. It's going to be a little awkward, though. I think we might want to jump them if we can. Here's a question. Do we need pull-up resistors for our I2C, or are those already provided for us? I think we are going to want, let's look this up, because I haven't used the Atmega 32 often enough. So let's go back to our data sheet here. Let's see. Let's look if the I2C. Does I2C really never appear in this? Is it called TWI, two-wire interface? I'm confused. What else is this called? It's called on the computer. Oh. This is really weird. I think the search broke. I think the search broke. What? Let's save this and open this in a big boy PDF viewer. Yeah. What? Why? No. Why is this opening in this? No. Okay, what was this thing called? This was called, sorry for the radio silence for a sec. Where the heck is this thing? Sort by, date modified. There we go. Group by nothing. Oh, we didn't save it here. We saved it in datasheets, didn't we? So let's go to ebooks, datasheets, state modified. There we go. And then let's look for, let's move this over here. Make sure I don't have anything OPSEC-y going on here. Nope. All right, and this is, let's put the stuff back on here so folks can see it. I squared C. Really? The letters I squared C never appear once in this entire data sheet. Does this not have, this definitely has SPI. Or it definitely has I squared C. I mean, like, it's going to be right around here. Yeah, this is SDA. So where's... it is called TWI. All right. TWI is short for two-wire interface. Technically, I squared C is a trademark of Philips, or NXP, but it's so the trademark is worthless now because it's so genericized. All right. So let's look for TWI. US art. Is this something we care about? No, that's the UART. Why do they give everything a weird name? What the heck? SPI. Where's our TWI? No, it's not called two-wire interface. How about TWI interface? There we go. It's for pull-up resistors. Pull-up resistors on these can be JTAG. Pull-up disable. And here, oh great, they use the numeral 2 here. Excellent. All right, the only external hardware needed is a single pull-up resistor for each of the lines. Okay, so we do not get built-in lines. Ideal Sound says, if those USB resistors are CC, they have to be 5.1K for USB 2 over USB-C. I don't think 1K will work. All right, I'll take your word for it. It's confusing as heck. I don't want to get demonetized by swearing on stream. Value, 5.1K. There we go. All right, so we need to, let's just copy this. Change this to 4.7K. Just your good old basic I squared C pull-up resistor. Why does this need pull-up? Why does it need pull-up resistor? You may ask. Well, that's because let's get rid of these labels. I don't need them. That's because I squared C is an open collector. It's an open drain signaling system. So basically, it's not. Basically, I squared C wasn't designed to use, like, for instance, 5 volts means high, 0 volts means low. Instead, the way it works is a high impedance means 1, or a high impedance means 0, and a low impedance means 1. In other words, instead of it being high voltage for 1, low voltage for 0, it is connected to ground for 1, disconnected for 0. And the reason they did that is because in theory, this lets you connect multiple devices to the same bus that have different logic voltages, right? Because there's never going to be enough voltage going through there to damage the system. And all right, fair enough, except that in practice, the way these things are implemented generally leaves them vulnerable to voltage. So you do still need, like, voltage converters for I squared C. All it does now is mean that every I squared C device ever now has to have a pull-up resistor. Now has to have a pair of pull-up resistors on it. Oh, legacy design constraints. You so crazy. So let's look into. All right. So let's lock in the rest of the GPIOs that we need. So our interrupt pin's pin 55, and that's right here. Oh, they're right next to each other. Isn't that nice? So let's get these guys. Let's give these guys some. Are there any GPIOs on this side here? We got analog 0 and analog 1, A0 and A1. Can those be used as digital? Remember, every corner we cut, everything we're too lazy to look up is going to be punished. So we have to look this up. So we're looking. So the question is, where's our schematic? How did it get moved over this side? That's weird. So yeah, question. Is PF7 digital, or is it just an analog input? So let's see, PF7. Let's see, ADC7. Pin 1. Port F serves as analog inputs to the AD converter. It also serves as an 8-bit bidirectional I/O port if the AD converter channels are not used. Port pins can provide pull-up resistors if the analog-digital converter channels are not used. So can you do so like would this require me to do any funky stuff with registers? These are all analog pins over here. Yeah, so well, let's do this anyways. So, all right, we're going to connect pin 36 to our pin 56 reset pin. And so on. All right, so let's name this. Call it not reset. Indeed. This one here is going to be called not interrupt. Very nice. All right. Route those nicely out of the way. Okay, the last one, we have two more or one more? One more. Output enable. Which one of these is our output enable pin? Here, let's take a look. Show not OE. Okay, it's this guy here. So we're gonna have to jump. We're gonna have to via this, and that's fine. We'll connect that to pin 38 of our TNC. There we go. Or not our TNC, our at Mega 32 U4. It's just not the same. Not the same. Doesn't have the same zing to it. Yes, let's connect them. Heck to the yeah. All right, now we got to wire these up. Yeah, there's nothing else to. We don't have anything else to worry about. We already have SDA cell. All right, so yeah, let's wire up our serial. So let's name these things. All right, let's name these guys. So we're gonna label them first. Probably should have done this when I adjusted the length of these wires. Should we just like for shiggles hook one of them up to the I2C bus? Yeah, let's hook the bottom one up. The bottom one's actually going to be on hardware I2, or hardware I2C. So it gets labels anyways, except naming those is super easy. I have one here because the pins are labeled, so I don't have to consult my memory. Because again, every single corner cut, every assumption is going to get punished. All right. Yeah, this thing's starting to take shape. This thing's starting to take shape. So this is 3-volt device and 5-volt bus. Is that going to cause us any problems? It's probably going to explode. I don't trust. You know what? Let's get these guys off the bus. Yeah, they'll probably explode. I trust this module the inverse of how far I can throw it because it's quite light. I think I could really get some distance. We're approaching 5 o'clock. I think let's route the pins that we've put up here so far, and then we'll sign off. Because I don't have a tremendous amount to do today except get that video online and take pictures of like 100 plastic boats for the next episode. I think I'm gonna split that into 2. So we got SCL on the top. Let's confirm it again. SDA on the bottom. So let's name this SCL1. There we go, and so on and so forth. Let's take a look at the old Chatsky. Let's see. Let's take a look at the old Chatteroo and find something nice to talk about. Electron Ash says, "Does Zack not read chat when he's in the zone?" No, I don't. I can see. This is what happens. Like when I'm firing all cylinders, I named the SDA1 SCL2. No, I can't. I can do exactly 2 things at a time. I can't do 1 thing at a time. Can't do 0. And I can't do more than 2. And right now, I have talking and hacking. So no, I can't look at chat and do this all at the same time. Let's see, S serial data 3. Let's take a look. Let's see who's got. Oh, we got a story of a dead cat. I'm not going to talk about that one. That's kind of sad. Let's see. We're rescuing kitties. We can't rescue kitties. Can't rescue the kitties. Let's see what else we got here. Old MacDonald had a farm. EIEIO GPIO. Har 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 har. What else do we got? Let's find something fun to talk about. Something about the AutoZone. Oh gosh. Oh gosh. Oh, we got some puppy snuggles. Oh yeah, we're gonna do some puppy snuggles. Big time. Maxtronics says, I have a question. What's your question, Maxtronics? What do you got? What do you got here? XMBCX mouse button control. Program mouse to be as hotkey or macro. Does the developer keep any rights on the patent? What does that mean? Does the developer of what? You get the patent. I mean, you get the patent before you develop the product. I just want to make that clear. I strongly recommend filing your provisional patent before you put a significant amount of work into developing it, because it's much easier to develop stuff when you can talk about it without putting everyone under an NDA. Yeah, should I have zero index these? Blownable. What are you going to do with all those OLEDs? These are going to be buttons. These are going to be buttons with screens on them. Sort of like the Stream Deck or a Loop Deck, except instead of it being BS, like having like one screen with a bunch of fake buttons on it, is actually going to have 6 independent OLEDs that click. Isn't that sick? That rhymed. Serial data 6 and serial clock 6. Valdorg says this project might put Zack into therapy. Every mistake, cut corner assumption, going to be punished. Oh, that has nothing to do with this project. This is actually a pretty forgiving project. This is a very easy project, all things considered. No, that's everything. You know, I forget to color correct one scene. It's all people talk about in the comments. I forget to replace the batteries on my mic, and volume cuts out, and we lose hundreds of viewers. Every mistake everywhere is punished. There's no escape. So let's wire all this crap up. So we're starting at pin 32. What are our GPIOs here? Our GPIOs PC7. What did this do that I disconnected it? Sebastian says SCL6 and SDA6 are reversed. In number 5. Indeed they are. Indeed they are. That would have been some fun down the line. See, everything gets punished. At least now I have some more people like looking over my shoulder. So let's wire this fun pucker up. Alrighty. So we've got these both open. So we have to remember serial data is at the bottom, serial clock is at the top. So looks like pin 32 gets to be our very first GPIO pin. SD serial data 6. Heck yeah, I want to connect them. And one next to it gets to be serial clock 6. Let's see what we got. Maxtronic says, darn, I missed my chance. That's what I get for typing like an idiot. Maxtronic says, if you're hired or commissioned to develop a product, do you keep rights as part of your payment? I assume you're asking, do I personally retain any rights to it? That's negotiated on a per client basis. Generally, no. Generally, the client has, and it's also not a patent. It's a copyright. It's a patent, not a copyright. You generally want to file a patent before you bring in anyone to develop it, because you know if you because like nothing stops them from filing the patent. Do I get my name on the patent? Absolutely not. No one would ever put a consultant's name on a patent. That's one of the biggest reasons you use a consultant. It's also not my idea. I'm being told to develop something specific. Let's see. Apparently, D+ and D- on our USB-C connector are also reversed. Minus is going to plus, and plus is going to minus. I just can't win today, can I? Just cannot win. Our D plus is here. And our D minus is here. I'm D minus 1 brain. Oh, I'm wrong all the time. I think it's important to acknowledge it. Ego, like, you can't consider yourself a rational person and have an ego at the same time. They're mutually exclusive. You have to pick one. Either you keep everything consistent with reality, or you feel good about or you get a. I don't want to say feel good about yourself, or you have a puffed up sense of accomplishment. Everyone makes mistakes. The world is too complicated for people to move through it properly. Yeah, I want to connect them. I want to connect all of them. Yeah, and plus, the sooner you admit to a mistake, the less people notice it. It's better to just quickly handle it without before too many people spot it, or before it has too many knock-on effects. So next up is pin 28. There we go. Serial data 4. And next to it is pin 27. Serial clock 4. Oh, this is going to be so easy to route. Oh, it's going to be so delicious. It's going to be so spiffy. Speaking of spiffy, get your butt to the store and buy some clothes. Buy the fanny pack. That I put that. I was just messing around, and that turned out to be so hysterical. I was laughing my friggin' head off about that fanny pack. Serial data 3. Oh, that fanny pack is so funny. I hope it's as terrifying in real life as I think it is. I'm definitely gonna buy it. The way I do business, I don't want to sell things unless, like, I don't want to sell stuff without playing around with the merchandise. Like it's part of being a respectful capitalist. If you believe that such a thing can exist, is you don't sell something you can't believe in. Why is PD5 not connected? What's the story here? What's wrong with PD5? Why is PD5 not connected? I'm going to confirm this. PD5 is it was an LED. Yep. It was a light emitting diode. So we're going to name this guy serial data 2. Yep, there we go. And we should probably throw a label on it so I don't confuse the living crap out of myself. We got our RX and TX. What are those going to? RX and TX. What are these I squared C? Oh, I connected the things to the wrong things. Connected them to the serial. Oh, am I a frickin' moron or what? Oh boy. There we go. Order is restored to the universe. All right, we're not going to need hardware serial, right? We don't need hardware serial on this thing because we have USB serial. Is there a reason to put hardware serial on it? Like, because it still enumerates as both a keyboard and a serial port. So, right? Am I correct here? It enumerates as both. I think it does. I think it enumerates as both. I've done this. I feel more confident in this because I've done it before. But let's check this. So the Pro and the Micro, the Arduino Nano, or this is a Micro. The Arduino Micro and the Arduino Pro Micro are roughly the same, except one of them is a bit smaller. So let's see. I'm just going to hook this up. Let's go to Arduino. Again, punished for everything. We're going to change our board to, let's see, an Adafruit AVR board. This is going to be a Pro or Pro Mini. No, we want the Micro. Oh, the dog's barking. I wonder why. He's been so much quieter since... Here we go. We got the Micro. He's been so much quieter since Edmund got adopted. He doesn't have to compete with his buddy. So this enumerates as an Arduino Leonardo. Why isn't this letting me file examples? Why isn't this letting me make this a keyboard? Because it totally can. We can keyboard this up. Where are our keyboard examples? Can you not make this thing a keyboard? I thought you could totally make this thing a keyboard. You would totally make this thing a keyboard. I literally have a keyboard with this in it. Or is this, we got, yeah, this is the Micro. Arduino Micro keyboard. Keyboard functions enable 32U4 or SAMD, Mega 32U4, to send keystrokes. Oh, all right. Well, then there you go. Okay. So let's see. File examples. Maybe it's just under like general libraries. Examples for any board? No. Communication? No. This is so sensitive. Jeez. I don't. Where's the keyboard? I don't see the keyboard. Where's keyboard? Arduino AVR boards. Like, I guess we could just burn this as if it were an Arduino Leonardo. Maybe that'll help in some way. File examples. Still nothing. No. Where's the friggin' keyboard library? Why? What? What the? What? Why? Oh, man. Oh, I just got really lightheaded. Oh, I just felt really lightheaded. Maybe it's time to call this quits. Oh. Man, I just had a real head rush. Man, that gave me a good scare. Oh, all right. Well, sorry about that. Maybe it's time to a little vertigo or something. That's weird. I guess I've only had most of a sandwich today. Yeah, I think I'm all right. I just had a really weird head rush. Well, I hope I'm not having a stroke or something. That would suck. That would be super awkward to have a stroke on stream. That would be terrible. Where's the freaking keyboard? I'm so confused. It is also very hot in here. That might have something to do with it. Where's our library? Maybe it's in the library manager. Stingray Master, thanks for the $2. No passing out. I am trying to avoid it. Yeah, Felderg is right. A stroke in this economy? Oh my. Oh, that was spooky. I'm not noticing any other signs of a stroke or a seizure. So I'm thinking it was. So it says it's installed. What the heck? Enables an Arduino board with USB capabilities to act as a keyboard. What the heck? This thing has USB capabilities. I'm really confused now. Where is our examples? Oh my gosh. Here it is. Keyboard. Well, you can include, does it not have examples? It's definitely got examples. It doesn't have examples? There aren't any examples for the keyboard library? Come on. Are you friggin' serious? We should just be able to like include keyboard .h, and that hopefully that does the job. Reagan says, so I saw you blow up a toaster, and now this? Yes. All right. Let's load this up. Oh, no, we don't want that. We want this. All right. So it should still be connected, right? Yep, it's still connected. And let's go to, I can't do it with the launcher. I have to do it from the system. Man, really rattled me. Health stuff scares the crap out of me. Device manager. This one time at Bandcamp, says Stingray Master, somebody today someone passed out. Keyboards. Wow, we have a lot of keyboards. Let's take a look. This is my mouse. This is the Space Mouse. This is standard keyboard on USB input device. This could be our boy. Let's take a look at our vendor ID and our product ID. Hardware IDs. We'll keep this off to the side and take a look at that in a sec. Properties. This is another USB keyboard. We'll move that one off to the sec. Move that one off to the side and look at it in a sec. Oi, Logitech Gaming Virtual Keyboard. That is the headset. And then this is another one. All right, let's take a quick look here. Although actually, we can just count these. We got 1, 2, 3, 4, 5, 6, 7, including the lance head, the mouse. So let's disconnect it. Count them again. 1, 2, 3, 4, 5. Is this enumerated as 2 keyboards? I think this might have enumerated as 2 keyboards. That's really weird. That's very strange. Oh, the bread is stale already. All right, so cool. We don't need hardware serial. That's how we ended up down this rabbit hole. Figuring out if we needed hardware serial. We don't. Now we can move on. So let's name this guy Serial Clock 2. Next up, Serial Clock 1. Oh, nope, I'm wrong here. We need Serial Data 1. There we go. And what's our next one? We have our I2C. We have our crystal. It's going to get a little awkward. And we have a ground 5-volt reset pin. What's pin 12? Pin 12, yep, here we go. And that's it. Serial Clock 1. Connect. Good. Good. Hashtag include flux capacitor. This isn't Python. Electron Ash says Zack can do 2 pull-ups in 1 day. I can do for somebody who literally never works out and is in terrible shape. I can do a surprising number of pull-ups. I'm pretty sure I can. It's been a while since I have. The last time I think I did like a good 15 pull-ups before I don't even know if I ran out of energy or if I got bored. Yeah, I don't actually weigh that much. I'm a pretty light guy. All right, let's switch over to the underside. Let's get ourselves some. All right, let's route these things. What time is it? 5:15. Brooke, how are we doing? Should we? Actually, we should be routing this in the other direction. Brooke, should I call it or can we keep going? Because I'm fine to keep going. I got to do all this work anyways. But I don't want to, tie you up longer than absolutely necessary for love reasons. Oh man. Arrow Raider says when Zack eats stale bread, it sounds like Handsome Jack eating pretzels and talking about how much they suck. The first 3 hours of that game is one of the funniest games around. and then it just turns into it's at least in terms of story. The gameplay is on all the Borderlands series is great, but like in terms of humor, it turns into a gigantic wet fart. Brooke says, "You actually fine to keep going. I feel like I need to eat something." Oh, that's a good point. That's a good point. But the content, yeah, I think we'll do a little more routing, and then we'll call this one off for for purposes of indulging my biological weaknesses. There we go. Alrighty. Brooke says maybe Veldurg says, Brooke, lure him away with a laser engraved Pop-Tart. Oh, that Pop-Tart. This is what people come here for. For a high quality content style video experience. I'm not gonna space those out. I don't think I have to. Alrighty. Out of the way, out of the way, out of the way. Alright. No, why is it not? Pick the thing I wanted to pick, you friggin' frick. I hate people who say fracking. I don't like you. You're an embarrassing person. Stop doing that. Just drop an F-bomb. At least, make something up about punting babies or something. Just don't make a friggin' Battlestar Galactica? Don't make a Battlestar Galactica reference as an interjection. Come on, have some class. All right. Well, let's. I think after I'm done with this, we'll wind down the show. Don't forget today's episode is sponsored by Next PCB. That's who we're going to be using to make this project. And no matter what you're making, Next PCB is a pretty freaking good choice. They got all kinds of services. Like, I didn't realize you can make like a friggin' 6-ounce copper board. I don't know what kind of nutcase you'd have to be to make a hobby project that needs 6-ounce copper, but they got it. And for the next I don't know, they're giving everyone 20% to 30% off. Reagan, thanks a lot for the super chat. He reminds us to not forget the merch store. We also do have a mailbox, Discord, Patreon. Oh, you were asking before if this thing's going to have ergobleds. I don't think this is going to have ergobleds. I don't have time to route all that. They're also, I don't know if they're any through-hole or, I think all the WS2812 LEDs are leadless. I don't think it's practical. Stingray Master, thanks a lot for the $2. Another vote for ergobleds. Yeah. I as much as I'd love to put some ergobleds in here, I don't think it's going to happen. So we still have a fair amount to route. Yeah, we still have a fair amount to route. We've got to lay out the Arduino part of this thing. We still have to lay out the other half, right? Because we've only done half of a keyboard here. So we gotta lay that out. Yeah. Halfboard says, you realize your head covered up the Patreon ticker for most of the stream. Oh no, I haven't been looking at my head so very much today. Oh, am I? Oh no, I'm leaning in. I knew I shouldn't have read that book. I knew I should have read that book about empowerment. Now I'm leaning in and I'm blocking the. Anyways, thanks a lot to all our Patreon patrons. Real quick, I'm just going to snoop around in the email and see if we got any patrons during the stream. I have been trying so hard to set up some system to automate this, and it just is not working. And it's making me sad. But these people, yeah, everyone who supports the channel deserves to be thanked. Thanked you shall be. No one. All right, well. Thanks, anyways. I'm just kidding. I don't think too many people are donating to Patreon during the stream itself. I think most people are doing it afterwards or when a video comes out or something. But thanks a lot to all these cool people back here. You people are cool. Again, thanks to our sponsor. Let's talk about what's coming up, because have we ever got a stacked schedule? Oh my gentle Jehoshaphat, we got some cool stuff coming up. Let's see. This is the 23rd, the 27th, I believe. Unless I'm forgetting something, Friday's episode, we are going to, unless I'm forgetting something, I don't think I am. I might be mixing these up a little, but I believe that on Friday, we are going to be taking a look at the brand new Anycubic Photon Ultra. It's one of their newest resin printers, and they say the quality and the speed are supposed to be like unparalleled. And first one's nice, second one I'm impressed with. But another so here's something that I really like about this. They are using a different design to protect. They're using a different design to protect protect the user from the ultraviolet, so it can have a smoked cover, which will make it much easier to photograph it, which is super nice. We're going to be taking a look at that. We're going to be doing some resin printing. I've got our resin setup is better than ever. I've got our fast. I found our Soraya fast resin, so hopefully we can bang out some cool stuff. Other things that are afoot. Revo Point has provided me with a 3D scanner, so Brooke and I are going to 3D scan each other, and we're going to let you watch. It's going to be very scandalous. What else? We have a 3D printer, Biku or Big Tree Tech. You might not have heard the name, but if you've been to Micro Center, you've definitely seen the name. They sell a lot of really interesting 3D printers and 3D printers and 3D printer accessories. And they provided me with a pretty neat Ender clone. It's very, very large. The box is enormous, and I'm looking forward to playing around with this. The Anycubic Viper. Unfortunately, it doesn't work anymore. I opened it up to do some maintenance, and I think I did something to the load cell. Now it won't level itself, so we got to figure that one out later. Procrastination. What else do we got? We got cool stuff coming on. Things wants me to do some stuff next month. We're going to be designing this project. We're getting a robot at some point. We're going to have a robot come in. That's for a future episode. But I think we'll play around with it first on stream. Just mess with a robot. I think that would be fun. I don't get to keep the robot, unfortunately. The robot is a rental. But it's going to be a cool-ass episode. At some point, we'll probably do a little more coding. Oh, of course, at some point, hopefully I can withstand such an onslaught of content, but I really like to do not a patron only stream, but I'd like to do a Q&A stream that we're going to take questions from patrons, and more information about that later. I know I haven't updated the patrons in a while. It's a pain in the butt. Oh, finally, last order of business, I promised Puppy Snugs, and we are going to deliver on the Puppy Snugs. Brooke, present the puppy. Puppy me. In the meantime, let's update our to-do list, because I don't want to forget where we're at. Yeah, we got a lot done today. We routed a lot of traces. Doesn't look like it, but we routed I think 120 signals, give or take. We still have 183 left. Welcome to circuit boards. A lot easier ground. They don't count. Come on, let's get a little pupper in here. Got a little pup. Oh, he's been such a good boy. The other day, I went out to the main room and Brooke was asleep and the dog was asleep It was very cute. Oh yeah, and this bastard peed on the floor in here. I yelled at him last time he was here because he peed on the floor. Come on, come here, Peter. Peter Pupper. As long as you don't pee on the floor, you're fine. Come here, pup. Come here, pup. I think he's too scared. I think he's scared because I engaged in a little dog shaming after he peed on the floor. We can't carry him, can we? He's too heavy. He's very cute. It looks like he's being a little shy. Yeah. We're trying to housebreak him, but I think he thinks carpet is grass. I don't think he knows the difference between carpets and grass yet. I think he thinks, oh, this is just like that patch of grass outside. Peter Pupper, come here. Do we need to provide him with a treat? You think a little incentive is? Think a little incentive is?
I think so.
You want a treat? Come here, pup. Come here, Peter. Good boy. Ah. Come here. Come here, pup. Come here. Let's switch to all the face all the time. Boop, boop, boop. There he is. Come here. Come here. You're allowed to be in here. You're just not allowed to pee in here. Come here, pup. Come on. Come here, Peter. He's not falling for it. Come on. I think he thinks we're trying to pull a fast one on him. He is very suspicious. That's a suspicious dog. Aw. I didn't even yell at him that much. All right. Well, looks like Peter's a little camera shy. So yeah, I think he's being a little camera shy. Anyways, thanks to everyone for watching. We got a lot done today. Apart from me almost fainting, this is a pretty good stream. Yeah, expect more in the future. I'm taking a different tone with the streams, and hopefully it came across. I'm taking them less seriously and focusing more on the project. Thanks a lot to everyone. Let's do one more final check for super chats. Everyone deserves their credit. Thanks a lot to everyone who supported the. Thanks a lot to everyone who supported the show. And next video is dropping tomorrow. And I will see you then. You know why? Because tomorrow is in, you guessed it, wait for it, the future.